Hello. Good morning. Yeah, I can't switch between languages. Like, I have to really think about it, and then by the time that I've thought about it, the moment has gone. So I can't say Guten Morgen. I just say good morning. Welcome everyone to day three. Sorry. So there's the Wi-Fi again. If you didn't get it yesterday, toilets are in the same place. Fire exits are in the same place. Lunch, yeah, same. So today we've got a block about SIP and PBXs at the beginning. Then we've got tooling. Then we've got lightning talks. No one's actually come to me with any lightning talks. Maybe. So I need to know if you're going to do a lightning talk, let's say, by the beginning of lunch. If there's no lightning talks, then we'll just move everything ahead and everyone can leave a little bit early. So we've got lightning talks, and then we've got operations, and then we've got coffee break at the end, and then at the end we've got a finale with our very own Marco. He's going to talk about live streaming with Mock. We are live streaming with Mock right now. So fun fact, you can go on the CommCon website, you can go to live streaming, and then you can go and select that you want not the YouTube stream, but you can say, I want the Mock stream, and you can see a stream being delivered over Mock instead, which is quite cool. But Marco's going to talk about all of that at the end of the day. And then it says here I've got half an hour for closing remarks. It won't be. Lightning talks, yes, come tell me that you want one, if you want one. And then our sponsors. So SIPFront, thank you very, very much to SIPFront. They are our platinum sponsor. Nimble Ape and Everycast Labs as our gold sponsors, and then our silver sponsors, Toulouse, Software Mansion, Jambones, as I got told yesterday, Cloudflare, SIPHub, and QXIP, and WebRTC Ventures and the Beacon Foundation as our community sponsors. But even though they all deserve a round of applause by themselves, I want to say a big thank you to SIPGate. Without SIPGate, this event wouldn't have happened at all. They said, we want to help make a CommCon in Europe happen. And I said, great. And they went and did most of everything that you see. I pretty much just did a CFP and selected some speakers, and that was about it. So thank you very much to SIPGate. They do an awful lot for the open source community, open source communities, let's say. They host the Camelio dev evening type thing that they do every year, is it? I think, yeah. They support lots of projects. They use lots of projects, etc. So yeah, thank you, SIPGate. I think that's the end of my slides. It is. So first up today is Razvan from the OpenSIPs project. Yeah, OpenSIPs. If you don't know what OpenSIPs is, Razvan will tell you. I was lucky enough to speak at OpenSIPs Summit a couple of weeks ago about WhatsApp calling, I think it was. It was about WhatsApp calling and the pain points of WhatsApp calling. So it works. Right, I'm going to hand this over to you. Thank you.
Thank you, Dan. Thanks everyone for being here now. Thank you. So today I will be talking about community edition projects that we've been working for the last 2 years. But first, a few things about me. My name is Răzvan Craina. I'm from Romania. I live in Bucharest. And I've been working for the OpenSys project since 2010, so it's 16 years now. I'm a core developer, but also the SIP Hub CTO. And I'm also a father of two boys, 5 and 1 year old. So that takes a lot of my time. Like Dan said, what is OpenSIPs? It's an open source SIP server used for real-time communication. It basically handles SIP signaling for VoIP calls or video calls or messaging, presence, and can be used in various scenarios like core routing, user registration, can do load balancing, SIP trunking, SBCs, PBXs, whatever. It's highly scalable and relies on a bespoke scripting language. It's very configurable and it's modular, so you don't have to load everything from the start. You can cherry pick the modules that you need. It's high performance oriented, but note we can ensure that because we are not doing any actual real time or media, um, we don't handle media at all. We just handle SIP signaling. And that grants us huge flexibility numbers. As I said, I work with OpenSys, but I also work for SIP-Hub, which SIP-Hub is basically offers commercial solutions based on OpenSIPs. We have different products. I won't get into too many details, but having SIP-Hub made us, so we are an open source, let's say, we are open source people, and we've always done open source stuff. How can we move from commercial products, or how to get to production products if we do open source? And today I will be talking about the community edition projects, which all of them are open source, and what they can provide and what they cannot, and when it's up to you to decide when you need something commercial. We started from the beginning. As some of you might have used OpenSIPs, you might have noticed that it has a very slow start. It requires deep SIP knowledge, and the setup might be complicated sometimes. It's a very abrupt learning curve. That's because it uses a bespoke scripting language. So in order to be able to use it, you first have to familiarize with routing, with SIP messaging, understand when the SIP messages call flow and how messages come and go and so on and so forth. You also need to integrate with several other components like media servers, because as I said, OpenShift doesn't natively offer any media capabilities. So you have to use something else for media, you have to use something else for database, have to use something else for billing. They're all in there, but you have to take them and put them all together, and that's not easy. The learning curve, it starts slow. So when you want to learn OpenShift, there's a huge amount of documentation that you need to learn and to read, learn, and understand in order to get it started. But once you get that, things become a bit simpler, and you're able to do a few calls. You are able to route calls as you would like. But then you'll get into more advanced, you will probably need to do more advanced features, and the learning curve starts to grow up a bit. And you need to learn more, you need to understand the internals. And then you become an experienced user, a pro, a master, and Bogdan level. For those of you who don't know, Bogdan is there because he's the founder and he's the most knowledgeable person in OpenShift. What Community Edition tries to address is this first hill. So it aims to get you started with certain scenarios that you might need to implement. So the goal for creating Community Edition projects is to simplify the OpenShift onboarding process. Our goal was to provide simple example, working example coming from real-time needs, but they have to be completed, easy to use, easy to deploy, and of course, everything needs to be open source. This is how we decided to do everything using Docker Compose, because it's one of the most familiar ways to deploy multiple containers in and configure them properly. We also try to do as much documentation as possible on how these projects work, what they provide, how to make them as easy configurable as possible. And the goal was to be able for any one of us to take it and provide us immediately a simple demo or proof of concept, or get something or have something to get started with. And of course, being open source, we rely a lot on the community's effort to develop and enhance and add more features to it. So we've currently released 4 different projects. So we have a soft switch, which is like a user-oriented product. AI voice connector, which is able to bring AI engines into SIP. IMS, for those of you who have used MVNOs and MNOs stacks, and SIP SBC. Probably all of you have used SBC once in a while. Let's get a bit more detail. So what our soft switch does, it provides standard calling services to residential users. It has a limited set of class 5 services like voicemail, and call forwarding, like class 4 services, call forwarding, do not disturb settings, presence, and so on and so forth. It also supports PSTN handling, so you can just deploy the sausage and hook one of your carriers, and you'll be able to do PSTN calls. And it has like a minimal provisioning interface based on OpenShip's control panel. In terms of layout, so as I said, it is Docker Compose. It is a Docker Compose deployment, which consists of, we can see here better, it consists of an OpenShip SIP server, which handles SIP traffic, the MySQL database, which keeps provisioning data, so persistent data. We have control panel, which is the web interface for provisioning the MySQL data and OpenShip's components. And we also use FreeSwitch as a media server for voicemail, for example. And of course, we also we are not handling media at all. So in order to make it work, we also have use RTP proxy as a media relay. But this can not easily be swapped with RTP engine. Getting back to the layout, here, I don't have my pointer with me, sorry. On the lower side of the screen, you have the SIP users and SIP carriers. So that's your, let's say, your user base and your carriers. And we provide everything above. We handle SIP and media. So actually the project handles SIP media, the data layer, and web interface. All you have to do is run Docker Compose, configure it with the proper IPs for your setup, run Docker Compose, and then you will be able to place calls between your users and carriers. It also comes with a testing suite, which is based on SIPCert. SIPCert is a different open source project that we've developed for testing. It's just Docker-based testing, automating tests, nothing fancy. It just orchestrates some tests to be able to run. The test suite covers different features that Sausage provides, and as well as various scenarios that we want to provide. And it's as simple as that. So all you have to do is run Docker Compose and run the test, make sure everything works, and then you will be able to run your own Sausage. OpenShip's AI voice connector. Basically, this is a bridge between SIP and AI engines. It's actually a back-to-back engine between SIP and different AI tools. It's written in Python, so it's very easy to extend. It has various integrations, and it can work in 2 modes. It can be a conversational AI or just a listen-only mode for transcription, for example, or summaries. As I said, it has different integrations. It can use DeepGram if you do conversational speech-to-text and text-to-speech services, but it can also do transcription. It works with OpenAI, so you directly talk to an, let's say, AI agent. Um, it works with Azure AI and Banafo. Banafo only works for transcripting because they don't have speech to text, text to speech right now. Well, but when we created it, they didn't have. I'm not sure whether they have it right now or not. In terms of layout, so you have the users that place calls. They end up in OpenSys, which acts as a back-to-back and controls the Python script that uh, handles both media and SIP. Actually, and signaling. It's not. It's no longer SIP. It's actually an OpenSIP's API. So it's not SIP, but it integrates with all the other AI engines in order to take media from the user to the AI and back. In terms of components, there are actually only two components: is OpenSIP SIP server, which acts as a back-to-back and uses the OpenSIP API to talk to the Python script, which handles audio and media, audio and signaling, and does the translation between whatever we are talking and whatever the AI engines are talking. It's very configurable, so you can create all sorts of you can feed the AI agents with all sorts of context. This can be done through files, environment variables, but also very dynamic. So whenever you start a call, you can dynamically provide context, hooks, whatever you want. Everything is configurable. And it's, as I said, it's written in Python. It's very easy to extend it. And for example, you can run Python code whenever the AI wants to call back a function. Probably the simplest example for this is whenever you're talking to an agent and you say bye, the AI engine will be able to trigger you a hook and say, okay, the user said bye, you can turn off the call. Or the user might ask ask to transfer to our agent, so you would probably send a refer and transfer the user to an agent. So you can do all sorts of these hooks in Python. OpenShift's IMS is it provides the control session control function, call session control function CSCF component in IMS. It's a fully compliant 3GPP specification and uses highly customizable diameter commands. So you can build the IMS engine as you want. All the diameter commands that you need to send to your AGSS can be crafted as you wish. So it's very easy to craft and extend it your current IMS setup. Our initial setup was based on Docker Open5JS in order to have the core network, actually Open5JS provides the core network. We just provide the CSCF component. Exactly as this layout shows. So we have the IMS core, we have the CSCF and IMS HSS. And well, the phones are here, and you can easily integrate it with application server or whatever you'd like over SIP. In terms of components, it relies on Docker Open5JS in order to create a core network. And then on top of it, we put the CSCF, the three components, proxy, interrogation, and serving components, which have different purposes in IMS. And also we have a control panel in order to tune the dial plan, provisioning, and also monitor how these components behave. So this is what this project offers. And finally, the OpenSys SBC, it is a SIP session border controller, which targets to secure and control SIP traffic between endpoints. You have core servers on your backend and users or PBXs or PSTN carriers on your as your clients, and you want to make sure they integrate in a secure and easy fashion. So that's what the SBC does. It provides NAT traversal features, topology hiding. It's able to do failover in case one of your core networks, core servers are not, or core applications are not properly handling calls. It can also do PSTN routing and other features an SBC does. In terms of layout, as I said, you have your on one side, on the external interface, you have the SIP users and your carriers, and on your internal network, you have the SIP core servers, and you want to hook these all these entities together for both SIP and media. In terms of components, we use OpenSIPs to do the routing. We use RTP engine in order to handle media. We have a MySQL database and a control panel to easily configure it. So as I said, the goal was to simplify as much as possible this setup. So if you need an SBC, just take this project and use Docker Compose to boot it up, and it will all work. Regarding using this in productions, these projects are not target to be used in production because there are several. I mean, it's not like they're not up to it. It's just you need to understand more what they are doing in order to make sure that you're using it right. They're just meant to be a starting point for your projects. They're not necessarily production ready. You'll have to integrate with your production in order to integrate it with your production platform. You have to adapt it to your network requirements. Have to adapt your wireless, your firewall, all your networks to properly route traffic. You have to hook them into your custom database with your user base, but also enforce security and access control through your firewall. So it's not meant to be deployed and used in production. You still have to understand what they do and make sure that they are properly secured to the external world. So in conclusion, what the community edition projects we've developed are targeting is to simplify the onboarding process with OpenSIPs. All these are setups inspired from real life, so there are products that people are asking us for, and we granted them as open source so that they can get started on their own. It's very easy to take one and use as a proof of concept or a quick demo that you want when you want to prove something. And again, we emphasize the fact that it has to be community driven. So the community should ask for features and we can implement them, or the community can implement them by themselves. But our work is not done yet. Actually, it's just the beginning because there's a lot of other things that we need to do in order to improve the existing projects. We want to add extra features, integrate other components, perform more tests, but also add new projects, for example, trunking systems or MS Teams integrations. We need to do that as well, and we want to do that. We have that on our roadmap. But we can only do that with your help, with the community's help. So that's why we insist community help is very appreciated and actually needed. And yeah, we want to find out new and nice stories about how you guys are using them. These are, so if you want to find more about OpenSIPs Community Edition, go on the website. It's ce.opensips.org. We have a mailing list for whatever questions you may have. And of course, the OpenSIPs project is the root for all of these. Thank you so much for having me here today. Thank you, Dan. And yeah, if you have any questions. Am I on time? I think I'm on time. Thank you.
Any questions? No?
That was
No?
quite clear.
You were very clear.
Yeah. Thank you so much, guys.
Thank you.
Thanks.
Next up, I think we've got Sam. I should know the schedule better than I do. Yes.
You may need to.
I'll get this plugged in.
Do you want to show on decimator entire screen, I guess? Seen that before? Need my glasses. Yep.
Okay.
Cool.
Yeah.
Let me just check I can then switch to demo stuff. Yep. Cool.
Right. Next up, we've got Sam. Sam's going to talk to us about Dragon PBX, which is quite a cool new thing. Yeah, no,
Kind of new thing, anyway.
It is. It is
Yes.
a cool new thing. I'll let Sam talk about it rather than me. Yeah. Yeah.
Okay.
Thank you, Sam.
Thanks, Dad. Oh, hello. That sounds very loud. Hi, my name's Sam Meachin. So my day job, I work for Jambones, or work on Jambones with Dave, and we build CPaaS, voice AI type stuff. So I'm predominantly a Node developer. Far too long in telecoms. First job was climbing cell phone towers for Orange as an apprentice, aged 18, quite a few years ago. So kind of full stack telecoms from antenna on the tower to software now. And I'm going to talk about Dragon PBX. So this is my new side project, we'll call it. It's a bit, it's the side project that then there are other side projects, which are the fun projects, and this is somewhere in between. So I guess what I want to talk about today is kind of the why, and particularly why in 2026 as somebody talking about building a new PBX. You know, we had lots of talk just about voice AI and programmable systems and all of this kind of stuff, but you know, PBX is that kind of boring white beige box that sat in the corner of the office. And I think there is still a place for PBXs. You know, we still need people, contact centers, environments. You know, people might not be necessarily all working in physical offices, but they still have some form of phone extension, and people want to contact with people, even if you're just from your AI transferring a call back to a human operator or something. So really this is kind of, I built this to scratch my own itch for a problem I was running into. And this is, you know, I've spent, I don't know, probably the last 10 years working with CPaaS, for one of a term I think it's gone out of fashion now, but you know, we all know what I mean, programmable communications platforms, Twilio, Vonage, Jambones now, Voice Blender, I suppose is a CPaaS, Cesare? It's a, yeah. The fundamental thing I was hit up against there was, and often even when we were selling or talking to customers with CPaaS, that CPaaS is an application centric, I would call it. So whenever you make a call or through a CPaaS system, it's generally a call to an application. The application terminates the call, does stuff, speech to text, IVR, whatever, gather, playback. Or it makes a call out. You initiate an outbound call from the system, it calls the user and connects them to the application. And if you're trying to do a sort of user-to-user call, you end up kind of doing the two pieces and gluing them together. So, you know, CPaaS is great for that interactive application, but when you were doing straight user-to-user calling, it started to get a little bit clunky. And really, there was an event I used to help organize, big hacker camp in the UK, and we built a phone system for that. So it's basically an internal PBX system with probably 1,200-ish extensions on it. Everything from decked phones, there's a whole thing with decked and hackers, but there's about 800 decked phones, 300 SIP clients, a handful of wired sort of SNOM desk phones, and some GSM. There's a small private GSM network. So all these extensions brought in. And in 2024, I did that with Jambones as our core PBX system. But Jambones isn't a PBX, and I had to kind of wrangle it and add some hacks and things to kind of make it behave in just simple stuff like number analysis and routing and things. So that was kind of where this came from. And yeah, we'll talk about. I've just kind of mentioned that the user gap. So the idea that in a CPaaS, you kind of have an inbound leg, you have your application, then you connect it to an outbound leg. And yes, some of them can kind of do this fairly seamlessly, but it's not the typical use case for a CPaaS. A CPaaS kind of is all geared towards, and you always feel a little bit like just stuff like the logs and the GUI just gets a bit confusing because users think it's one call. They're making a call through your system and out, but actually you've got two records in the logs because you've got an inbound call and an outbound call and that kind of thing. So where I wanted to put Dragon PBX was very much in the, it only works during the signaling, during the call setup. All of the programmability, if you like, really ends when the call is answered or connected. So it's all about the routing and not about the call side. So yeah, but also like what I wanted from this, native user, but also the thing I like about CPaaS is I'm a Python, Node, reformed PHP developer. I write web code, web applications. And CPaaS was great because it allowed non-telco developers to start building telephony functions using languages and frameworks they were familiar with, not free switch config, XML config files, or the asterisk dial plan with, that's here be dragons. That kind of stuff, we all know it, it's great. Or we all know it. But you kind of give that to somebody that's not a telco person, and it's a steep learning curve. But I think we just said on OpenSIPs, the custom scripting language, it's a steep learning curve. So I wanted to take the nice bits we have of CPaaS, of JSON, REST, all that kind of stuff, but for PBX. So that's kind of where we got to. Also, we still see people trying to use, let's say asterisk. I'm going to pick on asterisk because it's the most common, but and also it's the one that a lot of people that don't really, that's their first entry into the world of VoIP, and they come in and they, oh yeah, I've seen this asterisk thing, I can install a little asterisk on my Linux box on my laptop or whatever. And they start building what really is a CPaaS. They're trying to build kind of interactive bots and things like that using the dial plan. So they're trying to use a PBX really like a CPaaS. And what I was kind of also saying is at the same time, let's recognize that they're separate things. Let's not try and use CPaaS systems as PBXs and the right tool for the right job. So also what Dragon won't be. And I think when I was kind of scoping out what I wanted from this and how I wanted to do it, and there were some other reasons as well, I had a very definite, I wanted to do the one core thing and not everything. So it's not going to be another asterisk free switch. We're not going to have lots and lots of modules that can do, IVRs or all this kind of interactive stuff. It's not going to be an all-in-one. The idea is that it does the user-to-user, the call routing. SIP in, you've got endpoints with clients or trunks, and you've got some control of how those calls are routed. If you want to do interactive stuff, which I think is excellent, then that's where CPaaS is great. So the idea of Dragon is it kind of will work. You would deploy it in conjunction with a CPaaS, and that CPaaS might be in the cloud. That might be, but when you want to do, so you've got your office phone system. Let's take as a simple example. You've got lots of internal extensions and people calling, and when those are just sales calling payroll or whatever, those calls just route through Dragon and extensions. When somebody calls in on the customer support line and you want an IVR or something, you'd send the call up to Jambones, which would, you build your IVR on the CPaaS, and then maybe send the call back to the extension that lives on the PBX. So you've got this sort of separation of concerns. But it also means you're not trying to route all of the user-to-user calls through the CPaaS, or you're not trying to build an interactive system on the PBX. So again, the simple example here of a directory, I think that's a fairly good example. So most for business phone systems, that kind of thing, 90% of the calls are straight user to user. That might be DDIs to trunks or something. 10% are going through a menu. Voicemail, bit of an edge case. We'll come back to. I hate voicemail, and I'd be happy if we just didn't have it in the world. But if you really want voicemail, there is a little component for that. That's the only application that we have as I have as part of Dragon. So yeah, a little bit about the the technical architecture, the components. I also was building this very much coming at it from the Jambones space. So the first conversation that I had with Dave was, I've been trying to use Jambones as a PBX. It didn't really work. I had to make some tweaks and some changes. What do you think about kind of upstreaming those, and let's add more of that functionality to the config? And this was before I was actually working for him, and he quite rightly sort of said, actually, no, I think that's probably too, it's another complication. You've then got to you're creating this monolithic platform that does everything. How do we present that in a user if you want one or the other? So I said, okay, I think maybe I'll go away and build it as a separate component. But it's a cousin of Jambones, let's call it. So it has, very similar DNA. The code base looks very similar, mainly because they're both being written by me, and I've borrowed bits of the logic. So actually, if you're familiar with kind of the internals of Jambones, this shouldn't look a million miles away. It doesn't have the free switch component. It doesn't have a lot of the media stuff, but it is built on Dractio. Dractio is a fantastic SIP framework. Dragon is a Node.js application that sits on top of Dractio, exactly the same style as Jambones. Uses RTP engine as our media proxy, again, which Jambones uses for ingress media proxying. And we use Redis. So the three external components are Dractio, RTP engine, and Redis. And then you've just basically got a Node application which turns those raw SIP VoIP products into a PBX in this sense. So registration and everything is handled in Redis, all your expiries, that kind of stuff. So a client registers, you negotiate and expires based on what the client asks for, what you've set, and it stores that record in Redis with the appropriate expiry. So if they re-register, we update Redis. If they drop off, they just expire out of Redis. That's all taken care of. RTP engine handles our media transcoding, so we support basically any codec that RTP engine can support that you can compile into it. The kind of defaults out the box is 711, 722, Opus, and GSM, because I needed GSM. But AMR wideband, it's entirely possible. There's just a few things where maybe I haven't added like an option in the web menu for it, but you can just set all of those up. And then also, the config data over on the left. So there is some configuration. Most of the call routing logic, I say, is held in your application with webhooks, which I'll show in a bit. But the initial config of kind of, what domains do you support, what are your rules for where to send webhooks and things, has 3 different ways of deploying that. So simplest option, you can just have a single JSON file local to the application, which sets up, so if you're doing a really simple PBX with like 6 extensions and a trunk or something, and it's all fairly static, you just store that in a config file on the system. There's an API method, so there is another application, which is the Jambones web UI. So the web interface is a completely separate standalone app with its own little database, but exposes an API to the server to then fetch config, and that's what I'll show in the demo. So you can create trunks and clients and the sort of setup there via that, or just raw into a database. So again, quite pluggable. And again, I wanted to kind of be able to run this on some very small things. I've got a few projects where I literally run 6 phones in a field with a Raspberry Pi and 3 ATAs as the adapters. And it's a festival sort of thing. And that's a PBX, but I need it to run on a Raspberry Pi with just kind of a console access, and that's what I was using Asterisk for until now. So that was my sort of lowest end thing, and then but also scaling up. Okay, so our concept, we talk about endpoints. So that's a collective name really for clients or trunks. Clients, your standard SIP client registrar. So you register, map the SIP username. We have pattern matching to a webhook. So when a client tries to register, we can call a webhook for that registration. So you say any 4-digit extension that tries to register with this domain. This is the, this is the webhook to call, and it will do the initial auth challenge with the nonce, get the response, and then send that bundle to your webhook, and you decide on the webhook. So the Dragon PBX never even holds the password. The authentication is handed off to your application, or it can be in the config file if you want. That then returns what we call the dial plan, which is another set of rules that basically says, depending on for this endpoint, this client, if they dial a 4-digit number, trigger this webhook. If they dial a number beginning with a 0 that's at least 6 digits, so some simple sort of regex pattern matching, call this webhook. So you can, that is what your dial plan really is a mapping of numbers or regex number patterns to webhooks. And the simplest is just, star anything they dial, call this webhook. But you can do it a little bit of filtering, or if you want to have a few different parts to your application, and TTL. Similarly, trunks. So SIP trunks or non-registration endpoints. Either this is very, very similar to Jambones. So you can whitelist the source IP and say any traffic from this IP or this CIDR range triggers this this dial plan. Or you can outbound calls are sent obviously to a domain. Inbound, you can do authentication on your trunk if you want. So you can again trigger that webhook and say anything, call this, use this authentication credentials for this source, so it doesn't matter what the IP is. Or we have outbound registration, so we will register to an endpoint and treat it like a trunk. But if your carrier is requiring registration, or your carrier is just actually giving you a single number with a registration, like a lot of kind of small office PBX type systems, maybe SIPGate, I think is probably a good example of that. You get your business number from SIPGate or a couple of numbers, you want to register to those and then fan it out at your PBX. So we'll do the outbound registration and handle, you don't even need to know the IPs. It doesn't matter what IP they're sending from, because we look at the contact header and put some unique IDs in there and stuff to match it to your trunk. Domains, so everything within Dragon PBX is scoped to a SIP domain. So it's kind of multi-tenanted in the domain. So you can have pbx.sammachin.com as one domain and sbc.sammachin.com as another domain. And within all of that, they have their own clients, numbering plans. Everything is unique. It does mean that if your carrier can only send to an IP address, and amazingly in 2026 there are still carriers that say, oh no, we can't possibly send to an FQDN. We have to send to the SIP invite to a number at an IP address. So you can configure the IP address effectively as another domain, or as an alias domain, but it just means that only one account on the system can then use the IP address. So I don't like doing that. But yeah, dial plans, webhooks, and that's kind of an example of a very simple minimal dial plan there. So you can see basically what I've said is emergency calls if they dial 999 or 112. The dial plan is another set of JSON that basically tells what to do with the call. That's actually held on the local file system, so we don't even have to make a webhook for that. So whereas we've got webhooks to fetch JSON, you can just put a static JSON file locally. So an emergency call is a good example of that. We don't want to be making an HTTP request to a web server and relying on the web server. And that emergency JSON would just say, send that call out on this trunk, basically, and that's it. If they dial a 4-digit number beginning with a 1, we make a webhook call to app is the name of the server /internal, which is one application. If they call a number beginning with a 0, that's however many digits that is, 7 digits or longer, we call external. And if it doesn't match the dial plan, it just returns a 404, I think it is. I think that's again configurable. So you've got some pattern matching there. Yeah, inbound call flow. This kind of, yeah, guys understand. I've probably talked mostly about this, but stuff comes in. We match it to a domain first, so we check that there is a domain configured. We do the auth. We identify what kind of endpoint it is. So is this a trunk, and which trunk is it? We then map that to a dial plan. We fetch the call hook, so that the call hook is the webhook we send for a new incoming call, and that responds with a call script, which is a JSON file containing a bunch of verbs. The retry logic, this is kind of interesting but kind of fun. So when the call first comes in, we'll send the webhook out, and you return back some JSON that says dial this number on this trunk or whatever, connects to this number on this trunk, and that'll have a timeout, 30 seconds or whatever you configure. If that executes and it doesn't get answered, we don't get a definitive response code. So either we don't end with a SIP error or an answer, then it'll come back and retry. It'll send you the dial hook, get the call hook again. So we have this kind of looping around of it represents it, but we increment the count and we say, hey, no, this call again, we're representing this call. Count is now 1 count, and you can configure that number of count. By default, it'll come around 3 times to you. So you've got this kind of retry. You haven't got to be able to say, oh, do everything, and then if that doesn't work, do this, and then if that doesn't work, you can say, okay, try this, and if it doesn't complete, it'll come back to you and say, didn't complete, what do you want me to do now? And you can respond with something different in your application. And that might be you just send back a 404 or whatever. But it will retry until it gets a definitive answer, or you reach the maximum retries. B2B UH. I use Claude to do some of these slides, so that's why there's a few bits in here that I'm like, yeah, that's not really relevant. It's the only AI in this system. And then status hooks. Again, everything that occurs, we can just fire off webhooks with events saying dialing, timed out, that kind of thing. So, yep, the hooks, we talked about those. The reg hook is what happens on a register. A call hook is on an invite. And again, if you've used Jambones or any CPaaS, this idea of a call hook should look familiar. This is the number being called. This is who's calling, and so on. And the status hooks are just fire and forget. Okay, so these are the verbs. So this is the 5 building blocks that you have for call control. Announce, playing back announcements. Really, this is playback. But by default, we'll play back in early media. So you drop an announce in and a URL to a file, and it will play back. It'll either fetch HTTP or, again, local file system, play back this file. So if you want to play an announcement pre-connect or anything, you can set a flag to say answer true, and it will answer the call and send a 200. So if your carrier or whatever doesn't pass early media. But yeah, pretty simple announcements. Connect is probably the main thing. So that is where you want to actually now connect this call to, an address, and then is that a client or a trunk? If it's a trunk, you can identify the trunk by name or ID number. And you can do kind of parallel ringing and stuff here. So your destination, you can just about see there is an array. So we only have one item in it, but it's in the square brackets in JSON. So if you want to ring like 4 in parallel, you just put 4 in your array. So if there's 4 different addresses, and that might be trunks or clients or some mix, it'll ring all of those. First one to answer or get connected. The others will all be cancelled. So that's parallel ringing. If you want to do sequential ringing, you'd use multiple connect verbs. So you could say connect this one, then connect this one. If the first one connects, it's completed and it wouldn't progress on, if you like, post call. So because we've got a successful code. Response just allows you to send back a SIP response code. So again, that's your kind of, if you need to finalize it, and you can just send any code and you can add optional headers and reasoning. Pause if you want to insert some delay in what's happening because you like post-dial delay or something, but maybe you need to like wait for a retry on your carrier or something. And then record. So record is SIPREC. Again, this idea of leaning on the CPaaS to do the complicated stuff. You can drop a record in there and say, send it to this SIPREC server, of which Jambones is an SRS. So if you wanted to use Jambones, and that doesn't have to be recording. I haven't got it working right now, but I've got a nice little demo of live call transcription. So what it does is you make the call through Dragon, but we tap the record on that sends it up to Jambones. The Jambones application actually uses DeepGram to do transcription and sends you back 2 text screens, and you have a little web UI which basically puts what the person on the call is saying in subtitles. So just like watching a TV show with closed captioning, you can have closed captioning on your phone call if you want. Cool. So how are we doing for time, Dan? 1 minute. 10. 5. Perfect. Okay, we'll do a very quick demo then, because dangerous demos and all. So this is, well, first of all, this is the web UI for Dragon. You can just about see that, I think. Yeah, I can't see it. So we have this concept of domains. So on this system, I have 2 domains configured, pbx.sammachen.com. And then within that, I have a couple of patterns of clients. Is that viewer readable on there? Was it a bit small? Let's see if I can. It's a bit too big. Let's go back to there, maybe. So we configure a client, which we set up a rule to say whether it's kind of pattern, star, the authentication type, whether we're going to pass that off. Sorry, this is if you're this is if you're using, you can configure the password here. So this will be a full extension. So So the label doesn't really matter, but we'll call it 3000. Username 3000 and the very insecure password. Maximum number of simultaneous registrations, and then which codecs this client supports. So that will determine which codecs we will send in the invite. So anything that comes from the originator, we'll pass those on, but in addition, we'll add those and optionally transcribe to those. So if you've got GSM's a good example here. If it's a GSM system that needs GSM, but all your calls are coming in with G711, select GSM in there, and whatever the call presents with PCMA, we'll also add GSM, and then on the negotiation, it'll transcode. Direct is it's not really a codec, but I've put it there because it behaves to change the codec. That if you add direct, it will not do anything with the media. It won't even proxy it. It will pass the source IP address and everything straight through, kind of in the SDP. So it doesn't even proxy the media, and it obviously won't transcode. It'll just act as a SIP user agent. I've got a friend doing some fax machine and dial-up modem stuff, as you do in this kind of world, and he wanted no, I need the media to remain kind of unencumbered, so it stays on his Cisco boxes, and then your dial plan stuff there. Let's just cancel out of that one. So yeah, we have our clients. We have our trunks. So I've got a whole load of trunks for different Jambone systems, basically, because I mostly use this for testing Jambones. So validating by the IP inbound range. So anything coming from that IP address would be identified as the Jambones XYZ trunk. And if we're sending anything, that's where we send it to. And that's the webhook we'd call. We've got an authenticated trunk here with Andrews and Arnold. So this is my external PSTN. So I've pointed that ANA number at this Dragon PBX instance, and it will authenticate using that as a username, and there's a password in there, and it will send outbound to them with auth. So that's my kind of config for there. So this is a completely separate web application that just makes stuff available to the PBX node, which is refreshing and caching the config every 60 seconds. So you make a change here, it'll take up to 60 seconds to hit. And then this is my application. So is people familiar with Node-RED? We've show of hands if people have seen it. I love Node-RED. I do everything in Node-RED because I'm a lazy programmer. But this is basically just a Node application that returns a webhook. So we have our incoming webhook. We have a great big if statement here, which matches what the dialed number is, and then decides what to do, in this case, to return some, bigger, not that big, return our JSON with our call hook. So this is our connect. So we're going to, call will come in. It's mapped to a 1 4-digit number. We will set our caller ID. We'll set our custom ringback tone. So we have, as part of the early media, you can choose what file you want to use as your custom, or any file you like as your ringback tone. And then the destination is just the dialed number. So hopefully that's up. Client here. So I think this one is, it's 1003, so that must be 1002. Sure it's open. Close everything off the phone. Yeah. That's got sound, but there we go. Okay, so you can see that's playing, ringing on here, playing our ringback tone. Hello, and we're connected. But that's a bit, horrible, harsh American ringback tone. We don't like that, so we don't want to use US ringback tone. We want a nice dual tone 400 hertz, 440 hertz, UK, nice warm ringback tone. So I'll change that in the application. I've not touched the PBX. I've not done anything to PBX. The PBX is running somewhere completely different this time. That's better. We now have UK ringback tone. So that's, a very basic idea of everything's in the application. Everything is configured in your code, be that Node or whatever. And you don't have to touch the PBX. Once you've set up that basic principles, your individual day-to-day stuff is done in your app. And indeed, last thing. So this is some other examples of doing the same sort of thing. So that's a JavaScript app for returning the thing. It's a bit verbose because it's got all the catching stuff, but we've got JavaScript. Python can do the same thing. PHP, if you want to write your telephony application in PHP, or even Perl. So same thing in 4 languages. And I think summary. So yeah, that I'll put aside. That's about it. Perfect.
Has anyone got any questions for Sam?
Right, thanks, very cool. So having worked with jump-ons, the whole verb approach and webhooks is very familiar. In jump-ons, there's also support for verbs with WebSockets. Do you think that would be helpful in any way?
Yeah, I've thought about it. I've not yet. There's no reason why not, but equally, because 90% of this is done during the call setup before the call is answered. Like, you're not doing it's not really interactive in the same way. WebSockets are great because asynchronous, and you can have an ongoing call, and you can push a speak message or get two-way interactive stuff. This is more this is call routing, not interactive call stuff. So I think it's less useful. That's not to say I wouldn't add it, but you kind of need webhooks is the first easy one. And I mean, yes, the retry coming back round thing, maybe that's where WebSockets will become useful. There is some REST API to make requests to it, more really now for like querying calls, and is this call in progress? You can end a call with a HTTP delete now. So if you want to terminate a call that's in progress on the system, you can do that. And we've got like SIP refer in there. So I need to add I'm probably going to add a webhook to allow you to transfer a call on the PBX. So from externally, you can send refer a leg, or send a refer back, or transfer it to a new one. So maybe, yeah, I wouldn't say. I mean, I've said this is 0.7 right now. So the main, what I wanted to get in terms of functionality is there. Now it's the tweaking, improving how you use the stuff. So yeah.
Thanks.
Yeah, Dan, Sam, as usual, I'm blown away by what you've done here. It's really impressive, and you've done a really good job of explaining why and what. But the bit that I would like to hear a little bit more about is the how, and how you push it forward into widespread use. What I'd really like to see is it packaged and kind of integrated with something like Home Assistant or
that's interesting. So yeah,
Hermes or something like that.
I've kind of the pieces now. The code's done. I do need a bit more. Yeah, very much like Jambones. It's there. Here's the code. You need to install this. Is the packaging. So I think and distribution as to how I'm going to do it. I think a Docker build, probably Docker, maybe a Debian package, and also a Raspberry Pi image. I've been running this particularly for testing on a Pi, so I think I want to make available like here's an image, complete Raspbian or whatever, that you can just flash onto an SD card and put in, because I think a lot of the use case for this is running it like at home in your small office on a small box, and a Pi is ideal for that. You can it'll easily do 10, 15 simultaneous calls on a Pi 4. So yes. Rob?
Less of a question, more of a cool demo suggestion. Throw up an MCP server for your interface and then ask an AI to achieve a call routing job.
Yes. Yeah. Yeah. So again, the sort of the SDK. I mean, actually, that port of those languages that was done with Claude. I was like, I wrote to the Node one and said, okay, Claude, please create these. But yeah, MCP. Again, we have this for Jambones, but yeah, an MCP for the doc. MCP is the new docs, really, isn't it?
I mean, that interface is so clean, it kind of lends itself to that, right?
Yeah.
That it? Thank you very much, Sam. I think it's, I think it's quite telling that 2 new projects have arrived fairly quickly in the grand scheme of things. And both of them are API/webhook driven and not config driven. Next up, we have Joran from Sipgate. Thank you very much, Zipgate, for supporting CommCon and making CommCon 2026 happen in Düsseldorf. You ready?
I think so.
Yeah, I'll let
Yeah.
you introduce yourself. Thank you.
First of all, welcome to Zipgate, or Zipgate hosted event, I think. Yeah, we are all learning that. Oh, you hear me breathing. Yeah, welcome to Düsseldorf. Welcome from Zipgate here to the event. Hope you had a good evening yesterday, or yesterday evening. Had some good food, some beer, some whatever you wanted. Today's talk from me is how we use open source at Zipgate. We are not producing an open source system. We are not producing a blueprint you can use to do a product for customers. We do basically build open PBX for our customers based on open source services. First, a word from my side. The name is Jöran Vinzenz. I'm developer at Zipgate, and the numbers tell I'm old, basically. I'm working at Zipgate now for quite a long time, but Zipgate was founded problems here, I think. From offered products for residential customers and later on for business customers as well. At the moment, the focus is on business customers mainly, but we still offer some residential products or residential customer products. Since 2013, we are MVNO in the network of Telefonica, so you can get our own SIM cards. And if you were looking at the hoodies of my colleagues, they have our IMSI range printed on the back. So we have our own IMSIs and our own cards connected into PBX, which is quite amazing. From the very beginning, we used open source. Maybe I should use another mic. Then give me some. Hello, hello. Oh, that's better. Then let me just get rid of that. Well, so we used open source for the very beginning in 2004. I think it was Asterisk Wonder 2 and OpenSea. I don't know what version, but it was a very early one, I guess. And since then we stuck to it, I guess. And the components we use at the moment are for the telco part of it, mainly open source components as well. So we have, for example, we still use the CommaIlio. Sorry, Rajan, we are not using. Oh, sorry, you can't read it. We are using CommaIlio. We are not using OpenZips, but I think this is a choice from the beginning. We are using RTP engine. We are using Asterisk. We are using Yates still. This is not fully open source, but we use the open source part as well. And for sure, I think you all know Linux and MySQL, Postgres, whatever. And there are lots of other open source components we are using, not mentioned here. The Asterisk we are using right now is a very powerful PBX, and we used it since the very beginning. And since the talk says it's about carrier grade, this is the only thing which is not carrier grade from the start. So if you start with Asterisk, or I think with any open source PBX, you have these very powerful systems which can do a lot of things, like you have this dial application, you have the voicemail application, you have a queue configuration there, you can do everything you need right from the start, but you have to tackle these demons like dial plan or XML configuration or whatever. You mentioned it with Drush Radio, I think. No, what was it called? Dragon, yeah. So if you use the Asterisk as it should be, you have this endpoint configuration. All endpoints are known by the Asterisk. So therefore, all calls are known by the Asterisk, and all recordings and sounds and stuff is known by the Asterisk. So things like message waiting indication, busy lamp field, busy indication, whatever, is very easy. But if you think a little bit bigger, you get stuck everywhere between, I think, 200 to 1,000 endpoints. And if you think above that, where it becomes a carrier grade, it becomes a little bit a nightmare. Now think about 1 million clients connected to one single asterisk. Even if it would work, it would be a nightmare to debug because you can't see anything in the console output anymore. You cannot do logging because no disk is fast enough to catch the logs. And then on the other hand, you can split it up to customers. And in our case, we have around 5 people for each customer or 5 users for each customer. It would mean we have 200,000 asterisk instances. I don't want to orchestrate that as well. So even if you have this fully automated, you still have to route the calls to a corresponding instance. And I don't want to do that. So we looked around on the market, but we couldn't find anything from the open source market which is suitable for 1 million clients or 10 million minutes a day, whatever. It's just too much. So we had to come up with the idea, and the idea looks a little bit like this. We used the asterisk. Since we used it from the very beginning, it makes no sense to switch to anything else if we have the same problem with every other component as well. We use it in a distributed system, but not in a way that we put each and every customer to its own instance, but we route the calls by random to an instance. So we split up there. We orchestrate all the asterisk instances by CommCon, and we use the asterisk as registrar using the user location module, I think it's called. And BusyLAM field and message vindication is offloaded to another systems, getting the information it needs from another place. So nothing tells more than a picture. This is how it looks right now. We have on the left the phone connected to an SBC, which is CommCon. This is orchestrated by DNS or anycast IP addresses. Then we have CommCon proxy, which is a registrar. There we have a couple of instances, but the CommCon itself is very powerful. You don't need much instances of that just to cover 1 million clients. From there, we have a connection to the RTP engine handling all these DTLS offloading, SRTP handling stuff. Sometimes we do transcoding with that. And then we have a split to the subscription to all the PubSub stuff we have in ZIP. And the calls are forwarded to the asterisk. We use dispatcher for it, so we can drain an asterisk and update and stuff. And from there, we have a connection to an ARI service. Who knows about ARI? A couple of you. Great. Sure. So we have an ARI service which has done all the heavy lifting in terms of what calls goes where we have to have a channel or connection, what state the channel has, whatever. And on the other hand, we have these media relay services connecting audio storage, AI components, or the streams we have to get in and out of the stream. And from there it goes further to the right to another SBC CommCon to the carrier. So this is pretty much it. It's a very high level picture, so no details are found there. In this talk, since the CommCon is already carrier grade, the RTP engine is carrier grade, and the other components are made by ourselves, we concentrate on the asterisk itself. The asterisk is running on bare metal. I know it's old school and old fashioned, but we are Germans, we love tradition, I think. So we have these asterisks with all these components. In addition to that, we use telegraph and vector for metrics, pushing forward to Prometheus, and vector to push it forward to Loki. All of that is open source as well. Then we have an HA proxy to secure the asterisk for the hard HTTP interface from the internet, because Asterisk is very poor in doing that. Then we have Redis Valkey database as persistent database for our ARI proxy, connecting the ARI to Kafka. And then we have the Hub agent, which isn't open source, but there is open source components for that, I think, for Humor. The components we written are ARI proxy and a fast AGI server. So we have connections to database, to the Kafka, to whatever control we need over the asterisk. And within the asterisk, we choose to use very little components. We use the PJZip channel driver, we use RTP handling, we use the audio socket or the CHAN WebSocket. For the AI integration, we use a little bit Dialplan, more than I wanted to have, but Anyhow, then we have the AGI and the status application to connect our own services. The asterisk in these terms is very flexible, so you can choose what you want and what not. So in our case, we decided we want to have these RTP handling, we want to have the mixing handling, we want the zip functionality for the calls. We want to have external media and the interface control about AGI and ARI. But we don't want to have all this register, pub stuff, so we just don't load the modules, so it doesn't litter the asterisk during its running. It's very modular. Sometimes you can unload the modules, sometimes you cannot, because it's the basis of something else you might need. So you have to figure out for yourself. Since we divided everything and we route calls randomly to asterisk instances, we have a distributed systems and distributed problems. So everything we split up in the low level, we have to bring together at a higher level. For example, the call states. We cannot ask an asterisk about the call state of a device because the asterisk doesn't know. Most likely it doesn't know there's a call at all. So message waiting indication, busy lamp field, as I mentioned, we have offloaded to another service. We are not doing this in asterisk. Pickup is a nightmare. Transfer using the refer message in zip was a nightmare. In conferences, you have to get all the calls together on one asterisk so they can talk to each other, right? So we had some challenges, I would say, and these are some of them. But we have limited time, so I talk just about these two. Transfer the refer handling of zip messages and how we build up the platform in a time where we had no idea what we want to have. Hope you can read that. It's quite low. So the transfer. Have you ever had problems with zip transfer? Yeah, I think nearly all who came up with this. The normal transfer looks a little bit like this. You have three parties, Alice, Bob, and Charlie, connected to whatever PBX you want to have. It's always the same. And Alice and Bob are talking, and Charlie is on hold or is also talking, whatever. And then Bob sends a refer message to the asterisk to connect Alice and Charlie. And then the asterisk or free switch or whatever do all the magic needed to connect Alice and Charlie. Sounds simple, but it isn't simple if you don't have this one control instance. So again, we have Alice, Bob, and Charlie. The call from Alice goes through asterisk 1 and the other is going to asterisk 2. So if now Bob sends a refer message to any of these asterisks, the asterisk just declines the request because it doesn't know the other asterisk. This was a problem we had from the very beginning, since 2008, where we introduced our business product. And now we thought we have to tackle this problem. So what we did, since it's open source, you can contribute to the project. So we did what it is intended to do with an open source project, right? So we added the refer handling in the asterisk. This sounds very easy, but it is not. So we had to discuss the idea with the open source community first. We want to have two asterisks behave like one. We need to exchange the data between the instances, blah, blah, blah. We have to check the RFCs and how it is done in practice, because sometimes the RFC is not what is done outside in the world. So we have to check both. Then we had to implement the changes. There we had a little help from an external developer, thanks for that. And then we had to make sure we didn't break anything. So we had to ensure we have a regression test. Then we have to test the implementation itself. So we came in our lab and we tested if it's working or not. And then we finally did the pull request to the Sangoma or to the Asterisk project. And finally it got merged. And then we made some documentation. If you follow the link down below, you can see how it's working right now. Or you search for refer handling asterisk ARI. So what we did is, if we have this picture, Alice calls Bob and Bob calls Charlie, and they are all in a call. And then Bob sends out a refer message. We intercept the refer in the channel driver in the asterisk, and say, okay, if there is a refer message for such a call, just push it to ARI. Don't do any magic, don't do nothing, just push every information you have to ARI. So we have this ARI controller knowing all the calls, knowing over every instance, getting the information about what call ID with what call ID should be bridged. And then we are free to just make a simple call between both asterisk instances and bridge both calls. Sounds easy, right? Yeah, we got some headache with that. Finally, it works. These phones on the desks working now with the button they have. Annoyingly, customer wants that, but well, now they can. The next one, building the platform without requirements. So when we started the project, we knew we have to change our existing platform, but we didn't know how and what it should compete with, or what should it fulfill in terms of requirements. So we started in 2018, and it's a long time ago. Just try to remember when we had 2018 and what was the time looking. So it is 2018. Blockchain was still a major thing. For some of you, it still is. COVID was unheard of. Brexit hasn't been finalized. The actual asterisk version was 15, and there is no I at all. So this was the time where we got the challenge to build up a new platform, which should be suitable for today's problems or tomorrow's problems. So I tried to make a sentence out of it. So the requirement was build a future-proof platform without the previous limitations, with the possibility to integrate whatever will come. It should be modular, so we can rewrite parts of it. It should provide a simple, low-level API for the rest of Zipgate, so they don't need to implement Zip again. Encapsulate all regulatory and legal requirements, so no one else has to deal with that. And by the way, be fast. Yeah, sure. Sounds like a holy grail, right? So it was a little bit, it was a huge discussion within our team how we do that. So we came up with an idea. The low-level API was the biggest challenge because all the rest is only technical stuff we had to challenge. So the simple API, we came up with an API with two resources. We have clients and we have hubs. The clients is all signaling stuff, representation of the user, the number, the whatever you have. And the hub is the representation for audio. Everything you want to have with audio is represented in a hub. So you can connect hubs, you can playback something on a hub, you can record a hub, you can stream a hub for AI, you can stream a hub for whatever, you can stream into a hub from whatever you want, like AI. And a simple call to visualize look like this. We have two clients with their corresponding hub, which are connected, and so they can talk to each other. If we do it a little bit more complex, we have kind of this. This would be a three-party conference where all parties are equally involved in the call, and no matter who is hanging up first, the others are still connected equally. And for the users of the API, it doesn't matter on which asterisk instance this is running. So if the first call comes on asterisk instance 1, on the second call is coming to the asterisk instance 15, we bridge the call between the asterisk instances, so they have just one asterisk to deal with or one session to deal with. In terms of boundaries, we have this very low-level boundaries where we find the Gamma Ilio and the RTP engine. There we think about packages, streams, requests, replies, whatever. Mostly me and the team I'm working in, we are not dealing with that. These two guys, they are dealing with that. And then we have the asterisk with the RTP mixing. There we think about channels and bridges and maybe calls, maybe lawful interception and streaming, something like that, but not about features. This is coming to the next one. The call orchestration is done by our colleagues. There we have basic PBX functionality like simple call, maybe voicemail, something like that. And then even further on the left, on the right, we have specifics like an ACD implementation or AI integration, whatever, so they can focus on the feature and not on the replies. Maya, she was here yesterday, she left already, gave a talk in 2023 on CommCon, why we did it and how we did it to implement this API. If you follow the QR code, you can find her talk, then you can have a look yourself. So, where are we now? The idea was successful, I guess. So we still have customers. We didn't know it will come, but it came, and the AI integration was seamless since we got the functionality of external media in the asterisk. And colleagues of us made an MVP for AI integration with the asterisk and external media. So we just had to copy their homework, right? Had it made a little bit more stable, have it make carrier grade and fit into this API. But other than that, it was, they did the research we had to copy. We have a very fast development in terms of features from the moment we have this API settled. Because lots of people can now develop against this API we did internally to enable them, and they don't need to understand what is lawful interception, how is register, and what are bindings. It doesn't matter for them. They just have this internal API and can concentrate on the feature they want to have. And these are lots of teams in Zipgate working on these features right now, so we quite have a good pace for development. So far, 50% of our customers are migrated to the new platform. We try to migrate only customers where we can fit their needs. So we check the features they booked and they pay for, and then we port them to the new platform as we develop. The system we did, it is modular. We could theoretically drop the asterisk in favor of a free switch, and we have to just rewrite the boundaries between it. We don't have to rewrite the API we use internally, so we don't lose the benefit of having all the features for our own internal API. I think this would be a major step. More practical example is we built this ARI controller based on Akka. It's a Java library, which is, they changed the licensing model, so we have to change it. And now we're exchanging this with Spring Boot. And we can do that in quite some time, but for not rewriting everything or not get stuck with the basic idea, we are pretty fast. We have these domain boundaries, as I said. People working on the features don't have to deal with all the basic zip stuff or legal requirements, whatever. It's scalable. Since we intendedly route by random the calls to the asterisk instances, we have to deal with having calls on different asterisks anyhow. So it doesn't matter if it's 10 or 20 or 50 or 100 asterisk instances we have in the data center. Our focus is more on the basic zip stuff, so we can be more precise on specs and RFCs to our carriers we have or to the legal requirements we have, and we hope it's future-proof. We had some learnings on the way. Open source gave us a head start. So imagine you start with a PBX and a carrier grade, and you have to start with nothing on a green field, right? You have basically nothing, maybe some zip standards, and you have to start with the first line of code, whatever. It would be a nightmare. So normally you go to Sony Ericsson or Alcatel or whatever to give you some black box to put in the rack. So they give you the head start. But then you get stuck with the black box in your rack. So we took the open source. We knew a lot of it already since we started 2004 with it. And we have this community behind us. For example, we asked Dan to help us with the development in the first place. We asked the Sangoma guys a lot of questions. We asked Andreas Kranich to help us with the testing with Zipwise. So the entire community is very helpful if you have a question. It's open for improvements. For example, this transfer thing, we could just implement ourselves, push it to the community, and now it's ours, not Zipgate own implementation. What we also learned, open source is not for free. So you may be not paying something, but you have to invest time, work, whatever. In our case, we are investing money as well to make something like this possible here, or for support contracts for Kamailio and Asterisk. So for us, it's not free. Finally, I think open source is still a good option for us. We have very quick fixes. If we find something, we can fix it for ourselves and then push the bug report with the pull request to Zagoma, to Kamailio, whatever. We have no black box, so we can understand what we are doing there. We can see where the problem is or see how it's going. We can do the changes ourselves, and we can develop features. And I would say we are still happy with open source. Do you have any questions?
Tim has a question.
If it's not too painful, can you talk about the ACA licensing changes?
A little bit, yes. So they changed the license model. If you want to have the new versions for ACA, you have to pay for each and every CPU core it's running on. And in the first place, the ARI proxy and the ARI controller were ACA. And we have like 40 Asterisk instances with 16 cores just to run the ARI proxy. This is a nightmare. And so we gain no benefit in keeping it. So we change it for Spring Boot.
Any other questions? No? Thank you very much. Oh, hold on. One more.
Yes, I've built cloud PBXs in the past, also using Asterisk and Camelio. You've mentioned call pickup as one of the hard to implement. How did you do it if it's not a...
Pickup was one of the first things we did. Let me... Oh, you can't see anymore because I... whatever, you have a couple of Asterisk instances. You never know what Asterisk is hit with what call. But we have this controller which knows about each and every call in the system. So if someone dials *9, which is the quick dial for pickup with us, so you can use whatever you want, we pass the request for the user that they want to pick up to the higher level PBX functionality, and they check if the customer has an ongoing call in a ringing state, and then we make a lookup on what Asterisk instance this is running, and then we can forward the call from one Asterisk instance to the one which is running on, and there we push the call to the ARI controller, so we can bridge these calls together.
So you basically do free O2 from the Asterisk that is receiving? Or?
No. We place a new call.
Okay.
So this is where we use dial plan.
Mm-hmm.
We push it back to the dial plan and then make a dial to the other Asterisk instance.
Okay. Thanks.
Thank you very much, Joran.
You're welcome.
We've got a break now, so have some coffee or tea and eat some pretzels and lovely things. We're back in 25 minutes for, I think, tooling. Be back in 25 minutes.
Test. Test. Oh.
Hello. Please come back to your seats. Right, we're going to get started on our tooling section. You good? Yeah?
I am.
Okay, so this is Alexander from the Homer project. They've got very cool new stuff. I saw it at It was Camille World, wasn't it?
Yeah, it was
I saw it at Camille World. I want to play with it, but I've been holding out to for this talk because this one goes more in depth than the one at Camille World, doesn't it?
Exactly.
So, round of applause for
Thank
Alexander.
you for inviting me, and I'm very glad to be here, especially in Düsseldorf, because I'm from the city. About Home 11. So in Camille World, like Dan already said, we did first, let's say, release. We showed how good Home is. We did some nice demo, but unfortunately, it was no time to see what is under hood. Yeah, and in this today, I will try to be a little bit more, let's say, deep diving inside of code, how the structure it works, and why we decide of some components to use in Home 11 and just let's say rejecting from Home 7. So let's start. It's Home 11. Blah, blah, blah. So about me, Alexander Dvorkov. We are making Homer, Epic, and a lot of nice projects since 2011. Headquarters is in Amsterdam. And also here it's Hep Labs GmbH in Düsseldorf. Yeah. Thank you, Marcus. Yeah, it's nice t-shirt. We do research and development in open source, in commercial observability, not only SIP, also statistics, and et cetera, et cetera, et cetera. Yeah, like Zipgate guys already said, we support open source in Robinhood model. So we thank you for our happy customers. Use this money. We working also on open source stuff. So mission complete. Home 11 it's since almost 2 months already released. We did a lot of good job. We did from scratch all components, and yeah, it's completely redesigned. New technologies, and what we planned 2 years ago, it's what's happened. And what is inside? Inside Home 11 right now, it's not. It's just database and smart files. So here it's a list of we did it inside. It's all one application. It's no more Haplify or Haplify server and everything. It's or Homer app. It's everything one application. And you can, in config file, you can just enable, disable roles which this instance will do. It can be compiled on x64, ARM64 system, and can be run on Linux and macOS. We do actions, GitHub Actions, and it compiles for these packages for Linux and for macOS already. It's based on DuckDB and Duck Lake inside, and Apache Arrow IPC stuff, and Parquet files. With Parquet files, it's exactly the core components of Home 11. We use also OpenTelemetry protocols and line protocols inside. We can send data and collect logs, metrics, and more. So it's just overview. Of course, we use MCP support as well. So user interface is also inside. And HEP injection, it did not change. You can still use all your HEP injection, what you still use in Home 7. It's from Camille, Asterisk, OpenZips, Janus, and many more projects. So HEP-free protocols supported natively. And what we add here, it's OpenTelemetry and InfluxDB line protocol. You can send all metrics, like I said already. It's traces, and for example, yesterday it was a good question in Homer. it's somebody wants to exactly send all logs from Camaillo to Homer, and we exactly help him to do it. So you can use RCS log to collect all Camaillo's logs and send directly to Homer and to make search inside. This is how injection pipeline works. It's a little bit looks complicated, but it's simple. We have HEP agents, we have telemetry agents. It sent everything to Homer injection. We use DuckDB inside for compactions. It's stored everything to local SSD. You can move data to S3, to R2, Minio. You have a rotation policy, and of course you can use or UI or you use CLI to make nice and cool search. Also, it supports Flight SQL API. It's zero copy streams protocol. It's very, very fast and efficient. So Homer Lake query pipes, it's also simple. We can use our user interface, like I said already, or CLI to make terminal search. Or you can use Grafana InfluxDB gRPC protocol and query your tables or your data directly from Grafana and make really nice charts. And of course, like I said, it's you can move hot and cold data from instances if you have SSD and it's small enough, but it's not big enough, and you can, or you want to move data for historical archiving, you can use S3. It's Homer will be automatically move this data to your S3 instances, and of course it will be very, very cheap. So, and here how you can make charts here. You can use or in terminal charts, or you can use in Grafana. So in Homer 7 we used Postgres. Postgres is a really cool database, but unfortunately it has some limitation. Because for immutable transactions in telecoms, we don't need more features what Postgres provided. And also Postgres, it's row-oriented tables, and it's use a lot of space, and to make efficient search, you should use indexes. Of course, exists some projects like Timescale DB from Tiger Data, but unfortunately, it's like additional features, and it's not designed to be very fast. In Homer 11, we use Duck Lake. It's a columnar Parquet file. It's by default is lingua franca for data lake structures. In Postgres, if you want to write more data, you have to install new Postgres, and etc., etc. So it's a vertical Postgres instances. To read, it's also replica indexes. It's very complicated, and of course, you could not do easily time travel with timescale DB. You can do, but it's some limitation inside. And of course, store in Postgres, all data is stored inside of Postgres, and you could not extract it. Yeah, so it's not easily to get data and put to S3. It's almost impossible. In Home 11, in Duck Lake, everything is possible. You can do snapshots, time traveling. You can move your data easily from one instance to another instance. You can save your cost for storages, etc. We already received some feedbacks from users which migrated from Home 7 to Home 11, and it's very positive, especially in space, because by default in DuckDB we use Parquet file, so it's columnar database, and of course to use snappy compressions, it's very efficient, and what we reported is something like about 5 times less space you use for same data. So before we used 2 terabytes to store 2 weeks of data. Now we say it's almost 5% of usage. Yeah. So it's very efficient. But thanks Parquet, it's not our, let's say, the good job. It's Parquet job because it's all data stored in columnar. So if it's same data, it's very efficient to make compressions here. So it's not like 20% like usual zip, or if you use exactly columnar, it can be up to 60-70% compressions. Why Duck Lake? If anybody knows what a date lake, no? Okay. It's date lake. It's new, let's say, abstract format. Because before we were talking about Postgres, Oracle, DB, or MySQL, it's everything. It's inside one component, and you have this data files on your system, etc. In date lake, it's abstract process. So you have data like Parquet file, like I said, it's limbo franca for all date lake stuff, and inside you have catalog, which includes metadata where is data located. Therefore, it's very fast. You should not scan many files inside. You just ask your catalog where is your data located, and it's make a request. And based on top of that, we have Iceberg or Delta Lake, and we use here Duck Lake, which is more, let's say, simple and powerful, because you should not install many components inside, and it's everything inside of one home application. So Duck Lake is a part of home application, so you should not install it additionally. And of course, what I said, it's example how you can use in DuckDB. You can attach Home catalog inside. We store metadata in SQLite. You can use also Postgres or MySQL, and there's data located. And here it's Parquet file. Yeah, it's cornered stuff. And you can use simple SQL queries or even complex SQL queries to get all data, make some statistics, manipulations, and analysis, which is lightning fast. By Home 11, we also support with Apache Flight SQL. What does it mean? You can install Grafana, and you can install with InfluxDB protocol with supported gRPC, and you can send requests to Homer directly and get all data immediately in your charts. We support REST API. You can make your own scripts to get some pickup files from Homer, reports, text files format to send your customers. FlightSQL, it's like I said, is Grafana, and gRPC, you can use many instances of Homer. For example, in data center 1, 2, 3, 4, 5, and you can use one coordinator which will talk to each node and will collect all data at the same time and make it visible in your UI or in CLI. Another stuff mentioned before, it's right now Homer, it's not many small components like Amplify Server, Homer App, and many more. It's one single binary, which you can say now module A, B, C should be activated. It's coordinator, or ingest. Ingest, it will exactly does. We will do insert data to your Homer. We support HEP3 protocol. We can use, of course, UDP, TCP, TLS, and you can use also HTTP, HTTP2 protocols to send HEP data and ingest to Homer. In storage, we use Duck Lake Writer, and it's make Parquet files inside, and Node, it's make query to your storage where you can locate it. Yeah, so you can also use in one node, you can have multiple storage inside, so it can be hot data, it can be cold data. You can use RustFS, yeah, Minio is dead. RustFS to replace Minio, and yeah, or S3 as well. And of course, you have coordinator, which its main application, or let's say gateway, which give you user interface, which give you access for tokens, etc., etc., etc. How ingestion plan path it works. So you receive HEP packets. You have decoder. You have write workers. It can be multiple workers. Therefore, it works parallel. It's very efficient. We have sharded writer, HEP adapter. By HEP protocol, we use different buffers. We use different memory tables. And once it's next slides, we have this batch size, how many data you have to keep in these memory tables, and after some interval, it will be drop data to disk and write small Parquet files. And after, you can use compactions, and data will be compacted to single file. So you have multiple files, and after compaction, you just have one single parquet files, which includes columnar database inside. Tuning, of course, it depends how many data you send. It depends if it's normal setup, it's by default it's 10,000. By high PPS, you can increase with batch size to 50,000, etc. So I don't have too much time. Data layout, it's very simple. Right now, all files, all data what you have in Homer 11, it's just files. And here is the structure. It's called Hive format. So you have data Homer, you have catalog for data lake metadata, you have parquet files, and inside you have table, HEPROTO1 for calls, etc. And partitioning by data, it's Hive partitions. And inside it's parquet files. Same for LTLP, metrics, traces, and etc. etc. Like I mentioned before, we use by default the SNAPI protocol. You can use LZCP and another compressions. Of course, it will be more efficient, but data will be use more CPU to compress. Yeah. Yeah. So I have a little bit more time. So table routing, it's how it works. We have invite for SIP. We are talking SIP here, and TCP stuff. Invite will be stored in call, registration in the register, and etc. So it's nothing changed like it was in Homer 7, same logic. And of course, you can use by partitioning Hive path here. You can do select. You can get results, and it's very, very fast. It's milliseconds of data execution time. In OpenTelemetry, we store data in OpenTelemetry. You can send data from Camellia, OpenZips, FreeSwitch, and any Janus, any another projects. And again, it's already efficient, stored. Of course, you do some. We also support some scripts. You can make retention policy. You can compact data. You can make rate, etc., etc. So it's same query. You do request in OLTP logs. You can do search by call ID, by any other parameters. How to install? It's very easy. Like I said, it's one single package and one single binary. It starts config file. It's by default. It already works. Very many positive reports from customers. Users, let's say, which migrated from Homer 7 to Homer 11. Just we say great work, super. And it's simple, but it's not that. I'm not finished yet. So yesterday we have this nice talk with Lorenzo. So yesterday you said, what is about Homer? Yeah. So how games works? Yeah. Let me show you something. 1 second. So, oops, it's gone. So it's just simple demo, you know. For example, it's how data it looks like, blah, blah, you can make a search. And Lorenzo asked me yesterday, but do you support games? I said, yeah, we also have this Tetris, we have also chess, etc. Yeah, you can play. It's bot inside. I wrote bot, which normally it's smart enough, so it will take. So good. So also you can play net games with Tetris, net Tetris, and also net chess with your colleagues here. But Lorenzo said, chess. Who wants chess? Yeah. So Doom. Yeah. Do you know Doom? Yeah. So it's even pregnant test can run Doom. Said Homer can run Doom. I said, let me think about it. Yeah. So I went home and let me show you what I did. Okay, let me play. So, do you remember GOT mode, which code? And E, IDD, QD, Oh, works. IDD QFR. No, it's weapon. QFA? No, okay. Doesn't matter, but it works. IDK FR. Yeah. Yeah. It works. Yeah. Next time. So, Lorenzo, it works as well here. So, you can download it. It's already released yesterday, so you can download it and play Doom in Home 11 as well. So, and of course, you can play it in dark mode. Yeah? Here it works as well. Yeah. So, yeah. So I did my homework. Thank you so much. And of course, support open source. Before ask to open source support you. Thank you so much for our happy customers. You give us money to work on open source as well. Thank you so much. And,
Yeah, perfect.
so any questions?
Any questions?
Quake?
that aren't Doom related.
Okay, good.
Can you migrate? What is the process of migrating from 7 to?
It's a good. I wrote script. It's our users has also tested and it works. So you can migrate it. I will remove this dangerous. Yeah. So and you can easily migrate. Even for Tori, he asked me also migrate from Home 10 to Home 11. I also did a script for him.
Tori was the only Home 10 user.
Yeah, Home 10. Yeah. He's our, let's say, brave user. And yeah, he can also migrate from Home 10 to Home 11.
Fantastic. Thank you very much.
Thank you so much to be here.
Next up, we have Andreas from SIPFront. SIPFront are our platinum sponsor. So can we all give a round of applause for SIPFront, please? It is searching. There we go. Thank you very much, Andreas, for supporting us again. And I'm very much looking forward to this talk with the rise of the AI machines and what SIPFront can do to help us with it. Thank you.
Thank you very much. Yeah, I've been talking a lot about voice AI in the last couple of weeks at conferences. Today I'm gonna take a step back and talk about some basics, because I think when listening to some of you and talking to customers of us, there is still a bit of a knowledge gap as well when it comes to quality assurance. I'm going to talk about that today, about automated testing pipelines for WebRTC and SIP infrastructure. I'm Andreas, working in telcos since 25, 26 years. I just had a talk yesterday with Marcus. I think the first time we worked together was in 2005 or something. And it was about e164.info. Yesterday we had a talk also from the select folks about number portability in blockchain. That was way before that, right? So it used to be a very nice idea to put number portability into DNS. Unfortunately, never really took off. But yeah, that's where it started. I've back then at Zipwise kind of invented RTP engine, and it's super cool to see it thriving in all of those projects and being used a lot. And I've built like UCAS and CCAS platforms for a living since like 20 years, and I've seen a lot of the ugly things as well. And this is why SIPFront exists, right? Because over time, when I was like leading engineering teams, the bigger these kind of
projects got and the systems got, the harder it was to implement them or implement new features. And we really had the issue back then at Zipwise that people really got afraid of touching something because they knew they're going to break something else eventually. And that is why I started Zipfront saying, hey, we need to actually get this under control. And how we are getting this under control, I'm going to show you today. Back in the office last week, we were like, okay, we are always telling our customers use testing in CI/CD pipelines, right? Because that's the way how you do it since like, I don't know, 15 years in web development. How you do it, develop it, you do a git push, it's gonna be built in GitHub Actions. You do your testing with Playwright and Selenium and your unit tests and whatever. And then you deploy it and you profit. Right? That's the way how it's supposed to work. CI/CD in telco is more like, an Excel sheet of manual test cores and lots of prayers. And the thing is, it doesn't always work because in the end, you just do a small config change and it pops up in the press if you're really unlucky. Now you're like, come on, Andreas, I mean, it was Orange in France and it was like 5 years ago. It was a 1 in a million incident. Well, here's another one. You're like, but that's still a year ago and it was somewhere in Canada. There's another one. And you're like, but that is in Australia, right? Doesn't bother me as well. But you see, those are like the high impact incidents that we are meeting again and again and again with just doing small config changes. And I'm not want to be the party pooper here, but we do have an impact with the things we do, right? Every line of code we write might end up in an incident like that, and just keep that in mind. Now, why does that even happen? Because of this. Right, works on my phone, but I just didn't test the special route. I just didn't test the emergency call at 3 in the morning because, it's a hassle. And I'm already tired and I'm already done like 2 or 3 hours of upgrades of my SBC and my proxy and my PBX and whatnot. And I just can't be bothered doing this particular call. Or, I'm just gonna change a slight codec option somewhere in my CCAS system, and I'm ending up with a one-way audio issue at a 5,000 seats contact center, right? Because I just couldn't be bothered testing somewhere on site at a customer whether that's gonna have an impact. You might not even technically be able to do that from your manual phone, right? Or it works on my phone, but it causes a 2-second silence gap on WebRTC because I just upgraded the RTP engine to a newer version, right? I mean, it happened in December. A couple of our customers got bitten by that. Why? Because you are trusting RTP engine to just work, and it doesn't always, right? So it had a DTLS negotiation issue with WebRTC, a regression being introduced. And suddenly each of those WebRTC cores got on the core start a 2-second silence gap, right? And customers on the hotlines were obviously complaining. And it took weeks to fix that. Now, how do we actually test these kind of things today? Sam, you said on Tuesday you do 50 cores. Usually people do like 5 hand dial cores and lots of wipes, and that's about it, right? And then it works on your phone or it doesn't. And we always like, okay, but I mean, there are solutions to that. They might be hard or not to implement, to get rolled out. So why is it actually so hard? And the thing is, it's not about the testing itself, right? I mean, these kind of systems, these like telco systems we're dealing with, they are not always simple. They are pretty complex. And getting them test stable is actually not about the test automation. The test automation is usually quite simple. 1% of your efforts goes into test automation. The rest is basically architecture. How do you build your system in order to be test stable? And we are going to have a quick look into that in this talk. Now, yeah, it is complex. That's like an IMS reference diagram. The good thing about that is it's all pretty modular. And why that is important, we're going to look at that as well. But in reality, and we have seen this yesterday, and we have seen this today in all of your block diagrams that we were looking at with the Dragon PBX and Jumbones and Zipgate, it's all kind of like this, right? It's a web application doing WebRTC, it's a Camelio or OpenZips, it's an RTP engine or RTP proxy, it's an Asterisk or FreeSwitch, and it's Jumbones or some other voice AI system, and it's some MySQL or Postgres. That's about it, right? Now, the question is, how hard could it be to get this CI/CD tested in a proper pipeline? And the thing is, you can only do this if you can bootstrap that in minutes, right? Without any hardware resource conflicts, without having to ask your colleague, hey, can I actually deploy my changes on this staging system, or is it going to clash with something else, right? Rather than saying, hey, I can just spin it up and tear it down without any external dependencies. And if you can do that, then you can also test it in minutes. So the actual challenge of these kind of systems, when you want to do QA assured, quality assured systems, you have to build them in order to do it. So it's not like testing cannot be put on top of it. Yeah, you can, but in the end, if you design it in a way that's kind of modular, it's going to be reproducible, so every one of your developers can actually spin it up easily and quickly, right? And it's going to be ephemeral, right? So you can just throw it away afterwards, right? Then you can test it in minutes. So how hard can it be? You know, I'm more like Dan, the last minute guy doing this kind of presentation preparations. So I had to build one, and I had to build it fast because I just started like last week with that. Even last week, not yesterday, last week. And you guys know this, right? So Claude welcomes you with think fast, build faster. And that actually is a pretty nice thing to do with getting back to our emergency issues in the beginning, having the problem that you need to even more look into what your Claude actually did in this kind of code changes that it did. So actually, not I built one, but we, and by we, I mean Claude, because this contributor list is actually a little bit lying. It should be the other way around. So what I tried to do is create like an open source VoIP test rig in order to show or demonstrate or even try by myself how hard it could be to implement like a typical telco stack, not a test stack, a telco stack that is testable, right? So we've already seen that, and I tried to do exactly that, right? So reproducing in the quickest amount of time I could a typical telco stack with a Camelio for SIP cores, with an Nginx and a WebRTC application for WebRTC cores, RTP engine, of course, for the audio routing, Asterisk for the PBX stuff, Jumbones for voice AI, and a MySQL database, to store it kind of persistently. And the question there is always, how does that fit into your CI/CD pipeline? And the thing is, we have seen that with Dragon PBX and Jumbones and the block diagrams we have seen before, and with these kind of tests. You need to be able to test it, and you need to be able to simulate like end users, and ideally you need to do that completely confined in like a GitHub runner or on your laptop or somewhere where you do not have any kind of external dependencies, right? And there, Docker Compose obviously is a pretty nice tool to do that, right? To say, hey, actually, what if I'm putting all of those components into Docker images? That would even apply to Zipgate and the components you're having with Camelio, RTP engine, Asterisk, and all these kind of things. Even if you are running that on bare metal machines, nothing stops you from putting all these components into abstractable Docker containers, running it even in host mode, for instance, right? And just start it like that, still on bare metal, but in an encapsulated way that allows you to do the same thing on your laptop or on anywhere else, on a VM or something like that. And since I cannot be bothered by writing CP scripts, I'm just using zip front agents, and I'm going to show you how that actually works. So all in all, it was like 100 lines of Docker Compose in order to, build this kind of setup. And now instead of doing Vim on your staging system and editing your Camelio configuration file, which, for instance, at Zipwise grew to 20,000 lines of code, and you really don't want to touch it like that, right? And then secure copying it to production and restarting it, or maybe even using Ansible if you're fancy, right? What you really want is a repository where every configuration is a file in your repository, and if you touch it, it automatically runs like a test pipeline. And the way it actually looks like is like this. Let me make it a bit bigger. So that's not meant to be like the reference telco stack, but it is a telco stack. And there, basically what you have is essentially the configurations of what you might need. You have like an asterisk, you have like, it shows it like in a weird way, but you have asterisk configurations, you have Camelio configurations, you have your RTP engine configurations, you have your voice bot configurations and your web app all in one repo. And every time you change something and you push it or you get a pull request, tests are automatically being executed. And why? Because you might, if you're working alone on your repository, you wouldn't create a PR just for yourself, right? You just do your changes, you push it to the repository, all is fine. The second you are getting changes from other people in either internally in your company or from open source contributors, right? What you get is like, you get a PR and you need to review it. And usually what you get is like the code, and I just know it from my experience, right? Some code changes are more complex than others. And in the age of Claude, who can do like a lot of code changes in one commit, you're looking at it and you're like, could be fine. It looks okay from a syntax point of view and from a coding style point of view. Does it work? I have no idea. Yeah, I have no idea. So what you actually want is you want to have this particular system built and run in seconds, and like that particular system starts in, if you have it cached and you just do a configuration change in Camelio, it actually starts in 7 seconds, right? And it spins up an asterisk, a Camelio RTP engine, a web application, even MySQL, everything you need, right? Why? Because what you want in this kind of code review cycles, you want this, right? What you want is, you want to see, hey, I want to have a CI/CD flow in GitHub. Every time I change something, I want to have this test running and I want to see that it passes or it fails. Now, why? Because in a like modern time, in 2026, and everybody, essentially nearly everybody, except Dan and CG Rates, are using a Claude, right? So what you do is when you change your configurations, you use Claude, you use your Visual Studio Code, you use Vim, and you git commit and push it. What you actually want is you want your AI to assist you with that. So when I started this project like last week, I told Claude, actually it started off with basic Camelio configuration, registrar, proxy, cores are being routed via Camelio, and Asterisk was just there as a voice announcement server. So I said, let's simulate what Zipgate is doing, routing every core via Asterisk. So I told Claude, hey, modify Camelio config and the Asterisk style plan to route all internal cores via Asterisk. So what it did is, chugging off and doing changes, and it came up with the core flow, and it looks like pretty much okay, right? So once the change is done, what you want to do is you want to spin it up. You want to create all your certificates that you need for proper WebRTC tests and TLS and everything. You want to seed your MySQL database in order to have like test accounts in there. And then you want to automatically test it, right? So what we have in SIPFront is in GitHub, in the marketplace, an action core test, right? So you just tell in your GitHub actions, hey, run this actually test project. And what you get is you get all the zip and web traces, and you get the media statistics. And what you also get is like, when I do the PR, I get like this. And this is what I want, right? So somebody does a PR on my project, and instead of just looking at the code and being like, looks okay, but is it gonna work? I don't know. So you just wait until your tests are finished. And once that is done, yeah, maybe you can discuss with the other developer about style and, unit tests and these kind of things. But in the end, you know that none of your actual core scenarios are breaking. And in this case, when Claude went off to change the routing via asterisk, it was doing its thing, and in the end, you had like, hey, the test failed because core RTP established was expected but not seen on Corley's side. And that's exactly those kind of things you want to catch in your continuous integration pipeline and not in production, right? So are you using ZipP? Maybe. Are you using audio with that? Maybe not, right? So you immediately have missed that. So really use a test stack that actually can catch this as well. Now, so we had an error. I'm a lazy guy. So what I'm using to close the loop is GitHub, like the GitHub command. And I use the SIPFront MCP server in Claude. Why? Because I want to close like the development loop, right? So I want to have these kind of extra steps in there, the extra tools in there in order to get my problems fixed. And the problems are getting fixed by just saying, hey, use the SIPFront dev MCP because the test session, whatever, from SIPFront failed when routing by asterisk. And what Claude then actually can do, right? It can ask your test rig, hey, give me the end-to-end media statistics, give me the end-to-end zip traces, give me the end-to-end core logs, and then give me via GitHub the artifacts from your GitHub actions, from your Camellia configuration, like the Camellia configuration, the Camellia logs, the asterisk logs, the RTP engine logs, everything it has. And then it just analyzes it and says, oh, in that case, there was a 603 decline and blah, 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 and so it didn't went through. Right? And then it just does another run and just fixes it, and it worked actually. So that's more like the, let's say, easy parts, because what you can obviously do, you can do that with ZipP as well. And for me, it's more important that people are testing rather than which tools they're using for testing. But when we are looking into WebRTC and also voice AI testing, then it gets even a little bit more complex, because now particularly with WebRTC, you have browsers involved and things like that. You need to orchestrate that. It really gets problematic, right? So what I did for that is a pretty simple thing, saying, hey, actually, so this is the SIPFront project for this particular repository. So I just built tests, right? Actually, I didn't build it. AI built, because you can say, hey, just create me tests for DTMF, for instance, and it will happily do that. So we have tests for TCP cores, TLS cores. We do TLS security scans. We just check if Opus is going through. That was another issue. You can see it here. It took like 2 turns in order to get it right, because it figured, hey, asterisk in this Debian package that I'm using is just not supporting Opus, so it needs to do transcoding, and it didn't get the transcoding right at the first time, but then it did, right? So it gets really easy to get along, right? For WebRTC, that's pretty interesting, because when we look at how a WebRTC test actually looks like, we know when we recap, we have Nginx, we have Camellia, and we use zipjs for that, and maybe also my internet might work or not. But what you get actually is you run WebRTC tests directly in your GitHub runner as part of the whole rig. Obviously not in my case here, but never mind. The interesting part there as well is when you look at that and you look at the actions, you actually want to know, okay, what actually went wrong when doing that. So my internet completely failed. Sorry for that. I'm gonna just peer it with my phone. Maybe that's better. No. All right, let's try. No. Yeah, that's the pity with SaaS services. You need external internet connection for that to work. But what I wanted to show you actually is also voice AI tests. So we are going to go back to that once the internet is stable again. Let me check. There we go. All right. So just a second. The other thing I wanted to tell you while we are waiting for that to get ready is until 2 days ago, and excuse my ignorance for that, Sam, I didn't know anything about Jambones, right? I knew it existed. I knew it's being used a lot. And I had in my slides the black box saying, yeah, voice AI, Jambones, question mark. And then I was like, okay, how hard could it actually be to implement voice AI in this kind of test rig, right? So what I tried is telling Claude, look, here are the Jambones docs, put it into this particular test rig. And it did. And I told it, okay, use OpenAI as a backend, and it did. And I told it, okay, there's a voice AI test, run it, and it didn't work. And the reason why it didn't work was actually not because of Claude. Actually, it was, and I talked to that about that with Dave yesterday. You guys have forgotten to update your Docker images on Docker Hub. And that's also the issues that you want to catch with this kind of CI/CD pipelines in your development workflow, because what happened, Draft.io, with this free server they are having, they are using a beta version of OpenAI real-time, right? And that has been decommissioned by OpenAI last month in May. And the Docker image that's still online is from April. Now, if you are running that in production, right, and you just do a software upgrade to say, hey, actually, just relaunch whatever my system, it's gonna stop working. And the question is how long it's gonna take for you guys to figure out why it stopped working. And this is exactly also why you need to actually test this upfront. Because when I then said, look, instead of OpenAI, use Google Gemini as a backend, it kind of immediately just worked, right? So also for Jambones, it might be actually a good thing to do some automated testing, just saying. Okay, so maybe I'm gonna show it later to you if you're interested in that. So let's move on with that. Yeah, the plot twist. It's the thing is, if it's easy to test, if a system is easy to test, it's also easy to operate. Why? Because you have like confined elements that you can launch wherever you need to launch them. You can usually also, if they are like containerized and Dockerized, you can easily scale them. And therefore, if you can easily reproduce them and can easily just deploy more of them, you can easily operate them. So, you know this slide from me if you attended OpenSIP Summit or Camellia World. I was asking Claude to give me a good punchline for the final slide, and it said automate or die. but we already had the emergency things up front. So people are dying if you're not careful enough. So that's why I'm saying automate and succeed. Use testing, use a proper CI/CD pipeline, test more. And yeah, I hope that helps you. Thank you.
Thank you. Thank you. Any questions for Andreas? No? Yes.
So a lot of the bugs we see or the problems we see are with the AI, and it's the not even the audio level, it's the content level, or when people do, So how much does SIP front? I mean, it's all about saying, yes, we've got some RTP, or, but sometimes it's like, actually that RTP is just filler noise, or it's that kind of quite user level. So we still find that, I was saying the 50 test calls I'm making a day are normally because I'm actually listening to what's being said, and like it's using the wrong voice, or, these kind of problems. Does automated testing manage to determine which voice is being used yet, or?
Yeah, let's see if we can load. But in the end, that is one big part of the thing. Because, I mean, when we started test automation at SIP-Front, it was always like SIP getting the connection right, making sure that RTP is flowing. And that was it, essentially, right? That was like the end goal to prove. And now with Voice AI, that's just the foundation anymore. Because then, like, there are other levels on top. And those levels are about the performance of the content, like how long does it actually take for the voice bot to reply. And this is something that I can show you afterwards once this actually loads. But what I'm seeing with this particular test is, on LinkedIn, you see a lot of claims like, hey, we now have like kind of real-time human-like interaction responses, 200, 300, 400 milliseconds of response times. If you look at those results, it's more like 1.5 seconds, 2 seconds, 2.5 seconds. We've even seen it yesterday, like with the demos, right? Both from Dave, like 1.5 seconds for the speech to text to complete, another 300 milliseconds for the LLM, another 400 milliseconds for the text to speech. And then that even doesn't account in like the round trip time of the RTP in itself. So in the end, what we are looking at is more like 2 seconds of delays, right? And then that's also depending on how or what you are actually saying to the bot. If I'm just saying yes or no, the LLM might be pretty quick to answer, right? If I'm starting to tell it like a huge story of mine, right, then the LLM might take a lot of time to process that, right? So that is one thing. And then the other thing is also like what is being said, as you said, right? I mean, that's like the non-deterministic thing, and you just can't manually test your way out of that, right? So if I'm calling the bot today, once it's going to answer this. If I'm going to call it another time, it's going to answer that. The third time, it's going to answer something else. And if I'm doing that often enough, at some point, it will tell me anything, right? And that doesn't even account to like the performance shift of these hosted models at all. I mean, next week, it might get even worse, and I don't have that under control at all. So what you actually need is like continuous monitoring of these kind of systems. You need to run these kind of cores again and again and again and again, and just automatically test them. And that's what we do.
Any other questions? No? Okay. Thank you very much, Andreas. Automated SIP testing is difficult. I don't envy anyone who actually goes and tries and does it and do it manually and create something. You should just go use SIP-Front. They're our platinum sponsor. It's now lunch. Back here at 2:15, which means 2:15 for the Germans in the room. Yes, and then we've got lightning talk straight away. I think at the moment I have 3. So if you're one of those 3, definitely come and confirm with me. If you want to do one and haven't mentioned it to me, come and talk to me now so that I can plan. Go enjoy lunch and be back here at 2:15. Bye-bye. Hello. Right. Ooh, danger. Lightning talks. So, just because you hadn't seen enough of it, so should I time myself, or can I take 15 minutes? I'm going to have to time people anyway. I told David said, would it matter if I went over? And I said, no, we haven't had that many submitted. Now we've got 6. So sorry, David, you've got 5 minutes. Stopwatch or timer? I want a timer. 5 minutes. Right. Everyone ready for lightning talks? Yes. Right, start. So, hi, I'm Dan Jenkins. I create something called Dotty Boards along with Marco. It's one of our products at Everycast Labs. So the one that we currently sell is up on the board here. It's called an RNLI Dotty Board. It shows a map of the UK. And then there's lots of yellow dots around it, and they're all the lifeboat stations. And then when a launch happens, it makes a pager sound, because that's what the RNLI volunteers have. They have a pager that tells them go to the station, makes the pager sound, tells you where and what boat, and then on the map it blinks and tells you which station. It's really interesting to people that are interested in lifeboats, right? And then there's a counter in the top. So there's a T6 you can see in that picture there. So that means that there were 6 launches on that day. And you would be amazed at how often the RNLI go out. There are days where there are over 100 launches across the UK in one day. So pretty cool. And then we sell the board, we donate some money back. Back to the RNLI. 3 minutes 43 left. We've been working on new ones. So we've got all of these ones coming soon. An aircraft tracker, carbon intensity, tides, Formula One, space, markets, and sewage discharge. So these 2 at the front here. So this one is this is the aircraft one, and so you can see the pink one here is air ambulance. Yellow is Coast Guard, and so my point is, it's fun to play with hardware when you do software all the time. It's fun to play with hardware. Tim told me this for a long time, and then I started playing with hardware and went, oh, this is quite fun. So we made a product, and we've started making more products. This one is the sewage discharge one. So this shows all of the, we're missing some. We're missing Scotland. But these are all of the places in the UK. The UK's just had a huge thunderstorm roll all the way through the country. And so there's 555 outlets currently discharging and waste into rivers and oceans. There's over 15,000, so it's not actually a lot. But the other day there was only 20. So 555 versus 20, it's a lot. So you can imagine that's a window into a bucket. I won't say more. But you can. I added this just a minute ago. It makes a toilet sound. Anyway, I think my time is up. My point is, playing with. No, I've got 1 minute 47 left. I'm going to use them all. My point is, playing with something new is fun. We just did it. Did it naturally. Anyway, playing and learning a new skill is cool. We've created our own PCB that runs these displays. That was an insight in itself, and it just gets you out of your norm. So don't be afraid to go try something new, and then trying something new. The birth of the RNLI one was, I went to an open day and there's lifeboats and they go out on the ocean, and my kids were asking questions about how often they go out, and I was like, oh, make something that shows them. And that was the reason why I started building it. And then like I showed it to a couple of people and they're like, oh, I'd buy that. and then it became a product. So yeah, make stuff that makes you interested and do something new. So that's me, and that's Dotty Boards. Thank you. Right, David. Oh, if you have an idea of what you would like us to make as a Dotty board, let me know, and we might be able to make it. I'll tell you when you've got 1 minute left. Yeah?
Okay. Thank you.
Off you go.
Hello. Oh, that was loud, wasn't it? Good to see you. I want to talk to you about boosting the bandwidth of your human connection in the AI age, because we all love AI, don't we? AI can do all sorts of exciting things for us. But let me ask you first this. Has this ever happened to you? You're watching something exciting, and then all of a sudden, just when it gets to the good bit, that happens. Has that ever happened to you? What's the problem? Sorry? Well, what else is the problem? Bandwidth, poor connection. Yeah, here's the thing. It's a bandwidth problem. And I want to explain to you that in a conference like this, geek to geek, it's like a dark fiber connection. There's a lot of bandwidth. But when you step out in front of less technical people, it's like a sketchy Wi-Fi connection from next door, unless you go out of your way to make it work. And as you know, we've all become more sophisticated buyers. Business to business buyers do 83% of their journey before they ever speak to somebody. You know, they used to just Google it, didn't they? Now they're using ChatGPT or Claude to decide what to do. So 83% happens before they ever talk to somebody. That means there's only 17% left for you to do when you talk to people. And I wonder what the figure is for job interviews. You know, when you actually come to talk to somebody about your next job or your next consulting gig, how much space have you got to talk to them? Here's the stereotype I don't buy about technical people. I don't buy the stereotype that technical people are all introverts. And I don't buy the stereotype that making presentations is all about charisma and excitement. Don't buy that. What I think is technical people have spent a long time pumping this particular muscle, the technical muscle. They've been to college, they've been to university, they've got some domain experience. Then they get into a job and they get product updates and they never really work on that other side. And so what I think, so all the technical person has to do is work on that other side a bit so they can balance out. And let me share another concept with you. Was that a toilet flush, Dan? Here's another concept. Your technical prowess is very visible to other technical people. But when it comes to talking to less technical people, there's a volume control on your technical prowess, and it's your credibility and your visibility. It's the bandwidth of the connection with those other people. And of course, they might be the hiring manager, they might be the chief financial officer, any sort of technical person. And as I said, it's not charisma, you can engineer it. And here are the 7 types of engineering that you can do to actually get a better outcome. Well, outcome engineering is one of them. Then there's attention engineering. I want to focus on resonance engineering. Okay. And I want you to pretend that Dan, being the generous man that he is going to give everybody a brand new coffee machine after this, you know, just because we came along to CommCon. It's only pretend. Very quick question. How many people are going to rip the coffee machine out of its box, plug it in, fiddle about with it, get the water and the milk and everything, and just play with it without ever looking at the instruction manual? How many people would do that? Quite a proportion, but not everybody. How many people are going to get the instructions out of the plastic bag with a little knife that you use specially for situations like that? Then you're going to read it cover to cover in your favorite chair before you touch the coffee machine. How many people are like that? Yeah, and there's always someone. It's not wrong, it's just different. How many people are going to actually stroke their beard if they have one and ask themselves about their relationships with previous coffee machines in their life and what they'd like to get from this new relationship? No, but, oh, okay. Do you work in HR, sir? Yeah, just wondered. Okay. So what I'm saying is, imagine if you're trying to sell to or you're trying to communicate with somebody that's a manual reader, but you want to rip it out and start, you know, there's a clash, isn't there? So what I want to highlight is we should always think about the audience that we're serving, whether it's in a job interview or anywhere else, and adapt to their style. So in summary, in my last minute here, your credibility and visibility is what contributes to that bandwidth. And the more bandwidth you can get with your audience or the other people you're talking to, the better. It's not charisma, you can engineer it, as I said. Now, there's a chance to win a book very quickly. Who can name one of the engineering aspects, the 7 that were listed? Can anybody name one of them? James was straight in there like a rat up a drain pipe. And this is especially for you, James. And I also want to say that I don't do weddings and bar mitzvahs anymore, but there are other things that I do. Thank you. Thank you very much. Thank you.
No problem. Tim, you're up next.
Oh, would you like my deck?
He's found it. There we go. You ready?
Yep.
There you go.
So this lightning talk comes out of a conversation we had last night about the idea that you can't change the laws of physics. And it occurred to me that actually I had a physics lecturer who used to give a guest lecture called Nothing Can Move Faster Than the Speed of Light, and would then spend the rest of the lecture listing things that did. So I thought it'd be interesting to look at like what we've been doing. So we built this camera and we've been bitten several times by reality in the form of physics. And one of the early ones was gravity. So they put the camera in the car upside down, and when it went over a bump, the infrared filter dropped out of place and everything went blue. So, like, how do you fix that? Like, what do you do about it? Well, there are 2 answers, one of which is you replace it with a different camera module, which doesn't have a movable filter. The other option is glue. So glue actually solved that problem in the short term. The next one we had was heat. You know, you're putting actually quite often more like 15 watts into a little plastic box, and they overheat on a hot day. So what do you do about it? Well, aluminium. So you can radiate a lot more heat with a nice big metal heatsink on the back panel. So we did that. And then the next problem we had that was physics related was we found that the faster you went around a track, the less happy the mobile network was with your reception. So we quite markedly get worse bandwidth and worse results as the car goes faster. So at 160, you're getting, you know, whatever it is, twice as much freeze time. But it is fixable if you do an RTCP NAC and some other secret stuff, which I'm not going to talk about. But it's fixable by tweaking how you behave with the bandwidth. So the next one was speed. This was like, I was totally bemused by this. The modem has a built-in GPS, and it does 1 GPS sample a second. And these cars can move a surprisingly long way in a second, and they can change direction as well. And what we found was that they were completely wrong. So you can see this car is the other side of a river from the track. And that one went into the river several times. So, like, that's not actually true. It didn't. The GPS was trying to do an estimation between the 1 second samples. And in the meantime, the car slowed down massively and changed angles. And so it interpolated it off into the river. So what do you do about that? Well, there's 2 options. You can either replace the GPS, or you can just round it down to 1 decimal point and just say it's on that track, and that's good enough. It turns out that for most of the purposes, knowing where the cars are is what we care about rather than exactly where they're on the track. The guys have their own better methods of measuring speed than our GPS. So this one was a horrible shock. We tried a camera in a new kind of vehicle, and we got results like this. And it's resonance. So the car was vibrating at the same speed, or very close to the same speed, as the shutter speed. So we got this terrible effect. Like, what do you do about it? Well, the only thing we could come up with is that you have to use a global shutter as opposed to a slower shutter. So that actually does fix that, but you have to use a different camera. And somehow the colors aren't as nice. Anyway, so the answer is that actually physics is negotiable to some extent, but not completely. You can sometimes dodge the laws of physics, but you can't change them, which is what Scotty does in every episode. That's it.
Don't worry, I'm not going to be 5 minutes. I'm not even going to be 3. Okay, this isn't a lightning talk, it's a lightning question. There's a URL up there where I'm going to ask a question, but before I ask the question, I want to pose a scenario to you. Wakey. Thank you. How do we do transfers in voice AI? Every single customer I come across expects the transfer to go like they do with traditional telephony systems. And it goes like this. Ring, 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 ring. Hello, welcome to Acme Widgets. How can I help you? Oh, hi. I was looking to speak to Rob. I'm from Terabit Networks, and he's not signed the contract for the new network yet. Can you just put me through to him immediately? Oh, Rob, I've got Stacey from Terabit Networks on the phone for you. She wants to talk to you about the new contract that you're supposed to be signing. Oh, flipping heck, I've got so much stuff to do. Just get rid of her. She's always phoning me up. She's a pain in the backside. Tell her I will send it over by the end of the week. Oh, hi, Stacey. I've just spoken to Rob, and he says you're a real pain in the backside. And he doesn't want to talk to you now because he's quite busy. Oh. Gosh, I'm an AI. I wasn't supposed to say that, was I? I think there's a better way of doing it than that. We don't implement it like that. We do it like this.
Hello, this is the reception desk.
Hello, I need to speak to James about the quarterly handover, please.
Got it. The quarterly handover for James. Please hold the line while I attempt to transfer you to James.
Thank you, I'll hold.
James speaking.
I am just trying to reach someone for you.
This is the reception desk.
Thank you
I have
for
a
the
caller on
update.
hold who needs to speak with you about the quarterly handover. Are you available to take the call?
I cannot accept this transfer because the secure briefing room is under code red maintenance for the next 30 minutes.
I understand that the secure briefing room is under code red maintenance for the next 30 minutes and you won't be able to accept the transfer. I'll let the caller know. I'll go ahead and reject the transfer.
Thank you.
James cannot take the call and no detailed reason was provided.
Understood. Transfer unsuccessful and no detailed reason was provided. Thank you.
So I think when we do consultative transfers with voice AI agents, we should be forking new agents and throwing Chinese walls up between them. This comes out of a conversation I was having with Sam walking over to SIPGate last night because they're thinking of or working on implementing consultative transfers in their agents. And this is probably the best hive mind of telephony and AI people. So there we go. Transfer.applice.com, 2 options. Vote now. Hive mind, which way should we do it? Keep it simple so that people understand it, or compartmentalize our agents and trying to explain to customers that the agent forks in 2 and the 2 conversations are going on in parallel and you don't need hold music because you're still talking to the original agent. Would love to know what you think, and it's live. So. That's it? Yeah. Do you want to bring your laptop up and... Oh, no, it's split. That's not what I want. I want some consensus. Come on, people. I split it.
I guess, hopefully. So we started in 2020 with testing our new stuff we did, and we came up with pretty much the same. Then Andreas told us about this Docker Compose and CP stuff and stuff he did, but we did it before it was even cool. If testing is ever cool, I don't know. So we have this. Docker Compose with about 100 Docker container. No, kidding. It's about 30 Docker container, which are, yeah, quite everything we built in our team to simulate everything which comes from outside and goes to inside. And for everything we break or for everything we foresee we are creating some tests. And we have a little script which starts all the tests. And then you can see on the right-hand side what's the asterisk doing, and it's pretty much doing what it does in production as well. And left we can see the output of this, the scripts, if it's successful or not. So this is a way how we do regression testing for each and every thing we push into production, which is part of our delivery pipeline, and we do it before we push it even to GitHub in most cases. Sometimes we are not that good with this. Also, we are using zipfront, and we are doing stuff we are not good with, like audio testing. So we have a couple of test cases here at zipfront. They are doing tests all the time, but they will never fail because we are not interested in failing tests, but we are interested in the metrics they collect. And we use the Prometheus output from zipfront to collect the data from zipfront and push it into our own Grafana. So we can see the MOS values we have for the calls we pass through our systems. We measure with 8 kilohertz and 16 kilohertz codecs. Also, we did a little bit of stress testing. Here we see the delay the audio takes, and we have chains of bridges in the asterisk, and the more bridges you have in the asterisk, the more delay you get. And if we have like 60 bridges in a row, the delay gets up to 600 milliseconds and more. So this is something you have to keep in mind. This is something we see now because we have these testing with zipfront and our graphing here. And back to our testing. So it's quite green right now, so it's in a healthy state, I would say. And unfortunately, it's ZipP we use for the signaling testing, and it's a little difficult to handle RTP or audio in ZipP. So we made ourselves a little service getting the audio out of the asterisk like we have to do in AI scenarios. So we stream it out and we save it as a WAV file on the disk, and then we can hear to it. Hold on. We have this. There's an audio file now, and it's from a test just now, and hopefully we hear something. I think you know this sound. So we use it as a test sound with us as well. And the next step for us would be to compare the audio files with the intended audio file and calculating a MOS from there, so we can distinguish if the audio path is successful or not. This can be done without checking in anything, so we can't break anything. We do it anyway. So therefore, we have this regression testing and testing in the pipeline. To test everything we do. Also, most importantly, emergency calling. So we do test emergency calling in our production. We don't call 911 or 112 in Germany every time, but we do the tests like a customer would do, but we stop the calls for testing at the border to the next carrier. So we try to be very cautious. Yeah, that's pretty much it.
Thank you. Sam, do you need some help? You're okay. Do you want plugged in? More hardware. Okay. Good. So yes, another hardware hack demo thing. This is another little side project I've been working on. Are you familiar with the Raspberry Pi 2040, the Pico microcontrollers? So these are not Pis as in computers, these are Pis as in ESP32 controllers. This is an RP 2040, it might be the new 2350, but with an Ethernet on board. And it actually has a tiny SIP stack on it. And the idea is we have a little microcontroller and a string of NeoPixel LEDs. Unfortunately, it turns out the connector on these NeoPixel LEDs is crap. And my router may have just rebooted, which is going to be even better. But you can just about see the serial console on here. This will SIP register to the PBX as another extension. And then when you get a call on your, so the soft phone is also registered or whatever, your desk phone. We should, if we're lucky, no, because the router rebooted. But fortunately, I also have one I prepared earlier. The LED thing got damaged on the way over, which is why it wasn't going to play. We also have this
SNOM light. So here's our device. It's a little RP2350 Pi Pico controller with a WIZnet Ethernet controller. It's quite important that it's the WIZnet controller for this.
This is another version.
We've got our SNOM phone.
Slightly different, so you'll see.
Ethernet cable plugged into the phone port. So the auto config is one of the cooler bits of this. So if I pan up, you can see this is the SNOM web interface here, and none of the action URLs are set. So these are webhooks that the phone itself would make a call to when it gets things like incoming call or missed call or anything like that. So pan back down. So what we'll do is we'll plug this into the SNOM and we'll power it up with some USB-C.
LAN port on the back of the SNOM phone.
Okay, and the little LED, this is just using its local LED, will go blue. Now we can plug in an external LED strip and configure it to use 24 LEDs. I'll put a little video of that hacked onto an LED ring I had at the end. So the blue LED comes on while it's doing the configuration. This can take up to 90 seconds. Typically, I think it's every 30 to 30. What we're looking for is the LLDP broadcast frames that the phone sends, so link local discovery protocol to say, hey, I'm here. And the device will discover that it's got a SNOM phone plugged in. There we go. So the light's gone out. So we're all good and it's ready. So now if I call the SNOM phone, we'll use GSM for this because why not? And you can see the LED flashes red. And then if I answer the call, the LED will go purple while we're connected, so you can see that you're on a call, and when you hang up, it clears.
So yeah, that's the basic idea. There's kind of two variants. The first one I did was sort of the SNOM thing, which had some really cool auto config and worked with SNOM phones. And then let's just stop that. Then I kind of went, actually, let's do a generic SIP version as well. So same hardware, but one has a SIP stack, one has a LLDP and some auto config to reprogram the webhooks on the SNOM phone to plug in. But yeah, a little bit of hardware hacking. And don't put hardware that's a bit bodged together in your checked suitcase.
That's all my LEDs on my displays go missing. Right. Let's find the schedule. Because apparently I'm awful. Right. Our next speaker, we're running 3 minutes behind now. Our next speaker is Alfred. Would you like a handheld mic? Or would, yes? Yeah? Alfred works for WebRTC Ventures, and they are one of our community sponsors. Very nicely, they support us at every chance that they can. WebRTC Ventures run a monthly show called WebRTC Live. I've been on there a couple of times. I know other people in the audience have also been. Oh, that's Sam. Your time is up. I know other people in the audience have also been on there. It's a great show to watch to know what is happening within the industry. And WebRTC Ventures are actually very good, more so than us at Nimble Ape. They are very good at writing blog posts about cool stuff. It's something I envy a lot. Anyway, I will let Alfred get on and tell us about what you're going to be talking about. Thank you.
Thank you, Dan. Okay, so I'm Alfred González Trastoy. I'm a WebRTC developer at WebRTC Ventures, as Dan just mentioned. And today I'm going to talk about a media server migration that we performed for a client for their real-time production application. And everything started 2 years ago. And that year I had the pleasure to attend 2 conferences, and one being the previous CommCon. And at that time we were already thinking about doing this migration for the application, but we weren't ready. And then at the RTC On, after my presentation, someone asked me which media server we were using. And well, I said that we were using Curento, but we were facing some issues, so that hopefully we would be migrating soon. And just a few weeks later, we actually did it. So to put you in context, I'll show you what we were running and why we wanted to migrate. So we had a full real-time solution. It was running mostly on-premise on Kubernetes, and we had the typical conference meetings. We also had webinar meetings with multiple hosts or presenters. We had telephony for inbound and outbound, and a call center solution. We had recordings for the meetings and also for voicemails during the call center flow. And we added real-time transcription and translation as well. And the architecture looked a bit like this. And as I said, mostly it was on-premise. We only had some external providers like the SIP trunk, and some Azure services like AI Speech and Blob Storage. And clients would be connecting from their phone or from web, mobile, or desktop applications. And the backend, we had the Curento media server. As I mentioned, that was our media server. And some backend services to handle all the signaling. Then Coturn, MongoDB, and for telephony, we were using FreeSwitch, Java ESL, and other backend services to manage all the call center flow. And some media services for recording and transcription and translation. So why did we want to migrate? We had 3 main problems. Our meetings had hard limits at around 20-25 people per conference meeting. We're starting to see some issues during the calls. And for conference, for webinar meetings, starting at 120, we were facing issues like freezings or audio stopping to work. So this was a really hard limit. Then also related to cost and related to this, we had really high CPU usage for the load that we carried. And then our call center solution was a bit outdated. And besides all that, at that time, Curento was in low maintenance mode, so we weren't expecting any fixes or any new features anytime soon. And well, how to start planning all this migration? No? So there are 5 steps. The first one would be to list all the requirements for your application, the non-negotiable that you want to keep or have. Research all the options or the options that you find the most suitable for your migration. Plan the tasks, do the estimates, and do a POC and sequence all the features that you want to migrate. And then the actual work, which is to implement and test everything. And you do this until you build to parity to what you had on production already. And once you do the full migration with all the old capabilities, you can start improving your solution. So, well, as I mentioned, the requirements are based on the functionalities that we had. And another thing that we wanted is to have a simpler call center infrastructure and based on modern voice agents so that we could handle more complex call flows. And another constraint that we had is that we wanted to do this migration as soon as possible. And well, the options that we considered were Janus, Jitsi, MediaSoup, and LiveKit. And we've worked with all 4 in different projects, and all 4 are really good options. But based on our constraints, we found LiveKit to be the best fit, because for SIP or recordings or AI integration, some of the others were not as straightforward to implement or required more time, more development time. So we chose LiveKit, and well, for a few months, there was no clear candidate because LiveKit was, had the SIP integration, but it was not production ready. And the agents framework, which is the one that we use for the voice agent solution, was in early stages. But a few months later, everything was ready, so we decided to go with LiveKit. And well, all 4 options are really performant, but in regards to LiveKit, we were able to test it pretty easily. There's load testing tools from their command line interface that we were able to use. Also, it's Kubernetes native, and we were running on Kubernetes already, so that's something that we liked. And really important that it supported AI pipelines for our call center solutions, so that we could use, define a flow using speech-to-text, text-to-speech, and large language models. And other interesting things that it had, we had simpler telephony infrastructure with the switch. The recordings were easier to configure with default templates or custom ones. And it also has a broad set of SDKs for client or server, which matched our stack. And also a small bonus is that it has built-in React components, so that would increase the development speed for client side. And compared to the other options that we were considering, LiveKit is abstracting a lot for you, like the signaling or the media routing. So you have less low-level control, but you have faster implementation time. And that's something that we wanted, so it's another trade-off that we accepted. And now, before going into the main piece, which is the telephony, the new call center solution, this is the approach that we followed. It's a phase rollout. We started with the simplest, with a POC of the conference meeting, and then the webinar with multiple hosts. And we tested that, and the client loved it. It performed really well. So we followed through with all the rest. And well, the next piece was the telephony and the agents integration. And on the old solution, well, we were using FreeSwitch, Java ESL, and other backend services to manage all the flow. And it was, well, it had a strict script. It was a bit slow. It sounded unnatural. So those were the issues that we had. And with the switch now, we have just 3 pieces of configuration. We run the LiveKit zip server, and then using the LiveKit agents framework, we can integrate, well, we customized our voice agent for the inbound call flow. And then you just need to configure the call routing and agents dispatch so that a call is landed directly into a LiveKit room, and then you dispatch a voice agent into that same room, and everything happens there. And well, the use case, the idea is that the caller is reaching our number, and they usually want to connect to a human agent, and sometimes they know the name of the human agent or some kind of extension, or sometimes they don't, and they can provide a zip code so that we can route to a nearby agent. The next step is to check the availability of the human agent based on their presence on the applications, on the web, mobile, desktop applications. And then we perform the warm transfer, which is just send a notification to the agent to the human agent on their platform. And if they accept, both are connected into the same room. There's no routing in between. And if they do not accept, or they decline, or if the person is not available, we are offering to leave a voicemail for that person, or they can try with another agent. And as a last fallback, we have the human operator. So during this flow, at any point, the caller can reach to a human operator. And with this, you have a better solution for the caller, a better experience. They can go off script, they can ask directly some questions or send some request, skipping multiple steps. So you reduce what I call the time to human. And we follow a multi-agent design. So instead of having a big prompt with big context and goals for a single agent, we divided that into smaller agents, each one handling a small context. And this is easily orchestrated within the LiveKit agents framework. And we just do the handoff based on the caller's replies. And we had five agents. One was handling the initial request, just welcoming the user and trying to find the intent of the caller. Once they give the data, there's the search agent that is doing all the database queries and checking the availability of the user. And if they find it, then it handoffs to the warm transfer agent, which is notifying the caller that they are going to be transferred. It plays the music on hold, and depending on if the human agent is available or not, then we can hand off to the voicemail, or if the call connects, then the voice agent just leaves the room. But if it goes to voicemail, then it handles all the voicemail flow, which it triggers the recording service, and then we have the goodbye, which is basic goodbye. And with this design approach, well, we can handle more complex workflows. We can add more features, and it's more scalable, while keeping lower latency because there's smaller context and also less hallucination. But there's another benefit, which is that it's reusable, it's modular. So you can use some parts of these smaller agents into different parts, into different flows. And well, it has multiple capabilities, but I'll go quickly through this. We added some improvements like the zip code routing that I mentioned. So the caller would provide their zip code, and based on our database, we have human agents in different assigned regions, and we would be routing to the most nearby agent. And we used, to do this, we used LLM prompting. And also related to this, we were checking the agent availability, but we weigh the presence. So if they are active, away, do not disturb, or offline. And but also their role, because some roles have more priority for the transfer. And yes, and besides beyond the call center solution, we also updated the transcription and translation service. So before we were forwarding all the media to a service that was doing transcription translation. But after the switch, we found it was better to leverage the LiveKit agents framework and create a new agent that would be handling, it would be joining the same room and handling all the transcription and translation stuff. We were able to reuse most of the code that we had in the previous service. So it was great. And we also changed the recordings. We were doing a similar thing. We're forwarding the recording, the media to a recording service, custom built. But now we started using LiveKit Egress, which is a separate service. And well, it offers track recording, which is straightforward, and we use for the voicemails. But for the meetings, we use the room composite recorder, which is headless Chrome based. And the good thing is that you have default layouts that you can use, like grid or single speaker, or you can use custom templates, which are pretty easy to create. And the output, you can send it locally or cloud. And well, we also, with all this, we kept the same Kubernetes horizontal scaling, but we improved it a bit with all these LiveKit services. So the final solution looked like this. So we have the new backend with the LiveKit server, some APIs. The telephony stack changed from 3 to 2 pieces. And media services, we are leveraging also LiveKit agents and the egress. And we added a new cloud service for the Azure OpenAI. And the rest we kept, like we could have switched from Coturn to LiveKit Turn because they have a special service for that. But we were happy with Coturn. We found no reason to change that. So yeah, the results and lessons after all this process is that we got much lower CPU usage. For smaller meetings, the difference was not that high, but for big meetings, this was really noticeable. And we tested the webinar meetings as well. And in a real life scenario, we reached 250 plus participants, but the server was not struggling, so we are sure that it could go to 1,000 or above without issues. And one of the most important things is that we stopped having meeting performance issues when we had like big conference or big webinar meetings. And besides these stats, we now have a modern call center with a natural conversation. We can handle more complex flows, and it's also simpler. And well, we are using speech to STT, TTS, and LLM providers, but we can always improve on them by updating the models. And we are also open to more AI. We can add different functionalities like call summaries, conversation analysis, or voice assistants. And also important is that, well, as I mentioned, the recordings are a bit easier to configure. We can change the layout on the fly, and the infrastructure is also more scalable. And well, those are the things that we got, but there were a few challenges, and the ones worth naming are, well, finding the perfect fit is hard, because the more complex your WebRTC solution is, the harder it is to find a perfect fit. and you just have to weigh the trade-offs of what each one offers. Another thing that we found while configuring the SIP inbound agent dispatch, I found that the call was placing to the live kit room, but the agent was never dispatching. So you would be calling and the agent was not joining. And after testing and debugging, I realized that it was actually a bug. It was not a mistake on my end. And I reached out to LiveKit team, and after exchanging a few messages, they confirmed that the bug existed, and within a week or so, they fixed the issue. So we were able to implement the call center flow. And related to the voice agent, we had a few issues. The hallucination happened sometimes, and it's hard to reproduce. But we saw that the multi-agent approach was a fix. With a smaller context, this stopped happening. And since we were using multilingual speech-to-text, text-to-speech, I mean, we were experiencing some accent bleed. So we were using multilingual between English and Spanish. So sometimes it would say something in Spanish with English accent or the opposite. So we had to add some custom language recognition update to update the TTS target language and some pronunciation toning. And then, well, I already mentioned, but the zip code routing algorithm was a bit trickier than it sounded to get right. And just as a final footnote, Curento is now being maintained again, but they are not super active. And migrating was still the right call because we ended up with better performance, 0 meeting issues, simpler solution, and a modern call center. So yeah, that's what we got. Any questions?
Rob has one.
Thank you. Hi, with the live kit agents that you were using, I think you're hosting them yourself or you're using LiveKit's hosted service?
It's everything self-hosted, running on Kubernetes.
Okay. How are you finding the performance of the LiveKit agents in terms of memory footprint, CPU footprint of an agent? What kind of size hosts are you, or what kind of pods are you needing to run them on? And how many calls do you find you can get through an agent concurrently for a given CPU size?
Well, I don't remember the exact numbers, but for the media servers, for example, we had like 16 CPU cores, and for the agents, we at least had I think 4 8-core CPU capacity, well, with minimum maximum CPU usage, and concurrently, the load it was having, it was not super high. Like we didn't have many concurrent calls, so it was not a big issue to handle the CPU load. And I think it was we were handling around 10,000 calls per month, but per minute, maybe it would be concurrently 3-4 calls per minute. So it was not an issue.
Another question from Marco.
Thank you. So very interesting how you split the AI in separate agents, very dedicated. I found it like quite surprising how you have an agent just to say goodbye. So it's 2 questions. One is how important or how difficult is it to sort of transfer the context between agents so you don't risk maybe asking the same question to the caller? And how the other part is the caller ever aware in a way that they're interacting with different agents, or is it very transparent to them? This seems like a single one.
That's a good question. And well, regarding the goodbye, it was not only saying goodbye, it was also, well, it confirmed if the user wanted to do anything else, and if not, it would finish the call. And in regards to the handoffs and context, context is shared between the smaller agents. And well, you can configure them to not share it, but they are using all the same speech to text, text to speech, and LLM models with the same voice, and you don't even realize you are talking to different agents.
Any other questions? No? No. Thank you very much, Alfred.
Thank you.
No, good. There was no, it was good. You were perfect. Bang on time. Ah, I've got plenty of adapters. Yeah. So. How can you daily run? How can you daily run Ubuntu? No.
I come from the past. I'm the new AI guy and running Ubuntu. Even works sometimes.
There we go. Right. For our second to last talk, we've got Dan, who's going to talk to us about CG rates. CG rates is one of those projects that I've always wanted to use and then just never have for whatever reason. I keep looking for a project with a client that I can use it on. Hopefully someday soon.
Thank you very much, Dan, and once again, thank you for having us here because it's our first CommCon, so it's a big event to us. So, since we are new here, just a few words about us. We are a company a bit distributed, located in Bavaria, here in Germany, and with back offices in both Romania and Albania. And over 19 years by now, time runs very fast, of doing what we are doing. During time, we have done both wholesale as well as retail platforms, and by now we should understand what real-time processing constraints means and seriousness of system outages. About CG rates, it's a real-time enterprise suite. It's a combination of words, but what it is a framework which you can use to first of all satisfy your billing needs, and then all the infrastructure which comes together with that. It should be easily pluggable into existing infrastructure. This is mostly the subject of my talk today. It should be also future-proof. It should be able to accommodate new components in the future. I don't know, if you want a new communication switch, a new SMS service, whatever, even EV charging, which I keep dreaming about. And it should be non-intrusive into existing setups. It's open source software. All what we do is open source, born sometimes in 2010, first sources published in 2012, and started going and promoting it in 2013. And that was the turning point for us as a company, from integration company doing before voice over IP solutions to a software development company focusing only on CG rates. So we do no more integration nowadays. We have full sources available on GitHub, 100% Golang, and more than 450,000 lines of code nowadays. And the joke on me, written by humans. Also, we have consideration for community contribution. We have 3 branches today. The V010, which is official version, the conservative one where we are not allowed to push any more changes. We have customers running it, and funny enough, they don't even abuse our support anymore. Master version, which is the one which is kind of nightly releases of 0.10, which we improved with functionality and features. It runs also in production just fine. And 1.0, which is our vision about the future. Being a billing engine, we don't have these constraints of too often release. We have more constraints of having the software stable. It's a performance-oriented project. We are an online charging system. That was the primary focus of the project. So this is why we have put a lot of efforts into making it fast. We wrote, including our own internal database, with support to dumping on disk. So similar to how Redis is doing it. We have recently benchmarked it, and we are able to bill, or we were able to bill on a very normal hardware, something like close to 50,000 CDRs per second. So pretty and with cost attached, and that is pretty high number of billing records per second. Then we do everything asynchronously within microthreads. If you know Golang, you know this how easy it's to do that into Go routines. And then we have the API load balancer built in. We have in memory what I told you, database, and the architecture itself is modular. It's cloud ready, microservices, all this fancy stuff. And then it's pretty easy to enhance specific components because all our subsystems, they talk between themselves via RPC APIs. So you can just take one service and put yours in and enhance just that part. And then you don't have to, you are not limited anymore by AGPL, our license. It's a test-driven development. We have over 10,000 tests as part of our test suite, all again manually written. Since beginning, so this was before the AI came. CG rates appliances. So what can you do with CG rates? Primary focus online or offline charging system. There you have complex rating, unlimited bundles for the charging, CDR server, and high number of interfaces both in and out. Then a routing server, because it came complementary. Since we are dealing already with prices and statistics and stuff, we are able to do quite powerful routing server, including here number portability support for the routes. Then a complex rating, bundle support on the routing side. So if you get a number of minutes from your provider, like a block of 10,000 or 1 million minutes, a day, a month, or whatever, you can use that in your routing decisions. So as soon as these are out, also your pricing changes. Stats and quality of service support and channel limitations. So you can only send per supplier and per destination, I don't know, 10,000 calls. We also have a fraud mitigation server. Again, comes complementary with the billing. It's built in multiple subsystems, and it can be informative or reactive. So it can go up to shutting down some accounts because it detects something is wrong based on your thresholds. It also supports escalation procedures. Then statistics server, it's very similar to what other statistics servers are doing. It's in memory, so it's completely fast. It has predefined statistics using telecommunication like ASR, ACD, PDD, and it has also generic statistics, so you can use it for generic sums, diffs, averages, and so forth. Then another use case is having a resource server, so limit virtual channels, since the new IP-based services, they don't support channels. You need a way of virtualization of these static channels. So we support that per anything you like, because it's dynamic filters involved. So you can have channels per destination, channel per time, per any other filters you would need to. Then mediation server, this is a way of enhancing your events. So your billing events, they come in some format and you want to alter it, like enhance it by adding, I don't know, PayPal address or physical address or whatever, and or alter number format. And this all is possible via a dedicated module for that. Billing assurance, so you can calculate in parallel to what you have already. So there was this business cases when someone was doubting their own billing system because they had to compare to the remote and they didn't match. So they needed a third billing system which testifies the billing. So you can add this in parallel. Being an open source solution, you can do whatever you need to do with it. There are no licenses attached. And then lately we have even added an IP management service within CG and that was because of the needs. You know, the new eSIMs are sometimes in need of having static IP assignments, and most of the providers out there, they are doing dynamic IP addresses for eSIMs. So by having static IP addressing, you are able to do virtual tunnels or virtual links or dedicated IP ranges to specific customer. So this is why we have added that, because we already had access to mobile core networks, and then being there, it was just another functionality we have added. Then regarding the subject of my talk, what did we do to improve unification of various sources of billing and all in real time? So it's event-based, not CDR-based, although we support both. So here you can see a network, a diagram of our architecture, our internal architecture. On the left side, you see various input interfaces, and for example, diameter, radius, DNS agent, talking about the number portability and routing. Many are still doing with enum. And we even have a built-in SIP agent for SIP redirects. So if you want to route, you can send a SIP request to CG and based on the routing, you can get a SIP redirect back. Then open source support for with own libraries written by us for Asterix, FreeSwitch, Camaillio. OpenSIPs also, they were so kind and wrote their own module to interact with CG. And we also support Janus, so we can build Janus sessions as well. Then down you have some generic event readers, which are again fully customizable in form of some processor templates, which I'll show you. And you see all of these are simultaneously getting into the rest of the subsystems. As I told you, all of our subsystems, so all of this in center of CG, they can talk between themselves via RPC requests, so all API based. And then even the input interfaces, these are input interfaces services. So they can also send requests to sessions, and sessions, depending on the flags which are activated inside, they can call and make specific logic inside. And after the CDR is calculated or the authorization is processed, this can go forward to be exported. So we can send to any number of event exporters out. And again, this is generic, so it can adapt to your needs outside of CG rates. So regarding this, on the left side, the agents, they are implementing the communication switch dialect, as you have seen, asterisk free switch. They bind to specific interfaces. Being real time, they need to monitor and interact, so they must be able to hold the call until we certify that it's authorized. So we have done there, we have used their various mechanisms for various switches. And you can go so far with this unified integration that you can get authorization, for example, over OpenSIPs or Camaillio, and get the billing done into a real back-to-back user agent like FreeSwitch and Asterix. So you can spread all these requests, and then in the end, the CDR, it can come even from your CSV CDRs or flat store CDRs or any other way of source, any other source. So you can distribute in your networks the call how you want it and use various plugins to talk to the billing in the way you need it. So this is why we have put efforts into distributing it. And as soon as the CDR comes in, we need the pre-calculation because it was real time. So we need to merge these records together and form the final CDR. So we don't double charge the same CDR together with the events out of real time. Then regarding protocol agnostic templates, this were what I told you about. You can define some translations in some JSON in some JSON files, and this is the way how you can interact with all these flexible events which are coming from outside. So inside you can control both requests in as well as replies out. This is useful, for example, in case of Diameter, because Diameter is a complex protocol and there are so many flavors and interfaces. If you have to follow them all, it's hard to stay compatible. So we decided that we abstract this and implement the logic into these templates. Then you can control also what subsystems are used in on the CG rate side, and you have regep support for mangling different information. And you have unified datetime with time zone processing, so you can have various formats of datetime, which usually happens when you are dealing with different vendors. Nanoseconds duration parsing, and these templates are available for almost all or everywhere we need it, everywhere we got generic events. Because, for example, in case of OpenShips Camaillio, they send specific fields because you can configure that into the scripts. But in case of FreeSwitch and Asterix, you get the bulk of information and you have to select specific things out of it. So this is why we have these templates in cases where we need it. And this is an example of such template. This, for example, processes a CSV file. So it decides what information picks up from which part of that file. So here, for example, this is the origin ID coming from index number 0 from the request. The request is a line in your file. Then request type is coming from number 1, and this one, you see, it's a constant, and we directly push it as call. So we can take some of information from file, some information predefined in constants or smart defaults. Here you can also see how we modify the destination format, because this one also changes from place to place. So you use this specially craft search replace rules. These are similar to what VI editor, because we got inspired from them. And then you can queue them up from one out can be the in of another expression, and you can have quite powerful information inside. And these are extra information which you want to add up to your request. So this is how a processor template looks like. It also tells that, okay, I will put inside on the CGRate side into a field name usage. This one is into a field name answer time. So you take from request index 5 and put in CGRate request answer time. So you do this translations here. This is how ERS, like event reader services, mostly reading files, message buses, and SQL. So in the same generic way. So you can have any number of different interfaces for in. And then this is the sessions, which is like accounting satellite system, we call it. This is where the balance reservation happens, balance refunds, and also automatic debits in case of online charging. Then it's a central external API endpoint. We put efforts lately into making only one API work there. So even if you have different states like authorization, call start, call update, call end, you can still have only one API. And it handles session, multi-layer authorization, accounting stop, usage records generation, session synchronization. So we make sure that we are in sync with what the switch knows that it has inside. We can also force this connection when the balance runs out. Session forking in case of having calculations for both distributor, supplier, customer, so you can have multiple simultaneous calculations. And we also can have dynamic logic options. This is how an API looks like. So you see the event itself, it's just contains three fields: account, answer time, and destination, although it's up to you what you put inside. And then you have these API options where you define how this event will be processed inside CGRates. And this one tells us authorize this event with accounts, so with bundles, give me also an IP address, and calculate also the cost. And I want to also book a resource or to know if I have resources available. And I also want to generate routes for it. And this is how the answer looks like. I have an usage for accounts. I have a cost. So for this event, I can get multiple replies back from different modules in the same time. So all of this, they are working together into one API call. And then inside your module, inside your switch or our agent, we make use of this information and pass it back. So we inject it back into the switch. And all this information, for example, routing, you have two routes here, route number 3 and route number 1. This can be your gateway, your supplier ID, and it can be anything you like it to be. Then attributes is the one which is doing the mediation, so you can enhance your events. This is an example of how an attribute looks like. Again, the same event with 3 fields: account, answer, and destination, same API ops. And then as a result, you see this one was matching some attribute profile, and it was adding or it was altering a field request subject. So if I look now at my new event, I can see this subject being added here. So I can enhance my event in this way. And then there is the event exporter, which can send out the events. So there includes a message bus. And here, this concept is interesting because you can get your switch, your communication switch, sending you in real-time sessions or CDRs, and then it takes couple of milliseconds or few milliseconds to build it and send it out in the same time. So it looks like the events are coming already built from your switch and already formatted in the way you need it for your real billing system, because we are a billing engine, but you have to do an invoice out. So then you feed all these CDRs already rated, you feed them into your billing system. And you do that via various interfaces, or maybe you want to do billing for your customers directly, for your distributors. So in the same time, you can spread this CDR, which is already built, to any number of outsources. And then you have the RPC connections, which they bind the modules together. And this is, they contain basic clustering. You see, they have so many strategies and failover, first positive async, how they communicate and receive answer back. You can also send the request in parallel to multiple engines and see which one answers first and so on. And transport, you have JSON or GOB or even HTTP. And same valid for API server. Being all API based, you have their Golang specific binary RPC or JSON RPC plus HTTP JSON. So you can use that even for real-time configuration reloads and stuff. We support them all. So I try to be as fast as possible. We can discuss days about all what is inside. Thank you very much.
Thank you. Has anyone got any questions? No. No? Okay. Thank you very much.
Thank you also, Dan.
Thank you. It's our last coffee break. And then I'm just trying to find the time. Coffee break until 4:05, which is 4:05. And then our last talk of the day. Yeah, 4:05. So you got 25 minutes. Hello. Do you want to plug in? Oh, it's turned off. Come sit down. Zero minutes.
Okay.
You're most welcome. We good? We good. Right. Last talk of the day. No pressure, Marco. Last talk of the day. So, what can I say about Marco? He's an excellent employee. No, I don't do his reviews anymore. But he is an excellent employee. But he's been working on Mock recently, and all the fun and games that come with Mock. I'm going to let Marco talk about it rather than me. But yeah, Marco Vidonis, he's part of the CommCon team, he's part of the Nimble Ape team, he's part of the Everycast Labs team. And I couldn't do everything that we do without Marco. So give Marco a round of applause.
Thank you. So last talk of the day, CommCon finale. So how to stream your conference with Mock, actually how we've been streaming CommCon 26 with Mock. So, hi, I'm Marco. I've been part of the team since 2021. We, as you know, specialize in real-time communications, WebRTC and VoIP, our day-to-day, basically. We provide full-stack solutions, and in my spare time, I like sailing and running. So my first CommCon was 2021. It was a live stream virtual event back then. So we had live introductions and Q&A with pre-recorded talks in between. And when, well, we've added an embedded matrix chat for questions from the audience. And when the event wasn't going, the player would switch to sponsor videos on demand. So basically we had, we built the player and we built it to provide a mix of, well, essentially two ways of streaming. We did low latency HLS and also WebRTC via Millicast. So we're not new to the idea of streaming a conference with real time, actual real time, less than 1 second latency. So essentially this year we want to do it again. And I thought, why not do it with Mock? So first of all, I'm not gonna go and tell you again what Mock is. We've had many great talks about, like, smarter people, how Mock works, what it is. We even had two yesterday, so I'm just gonna assume we know what Mock is. And I'm also not gonna get into the camps of we are better, you are better, why do Mock, why not do Mock. I'm just really much going through the, going from the point of view of a user, wanted to, live stream my conference with sub-second latency. I want to use, pick the tools that are available and let's see how can I do it, basically. So I decided to try Mock because it has some really interesting features that I find, are quite unique actually. So you can get, because of the way it's set up, basically, you can get sub-second latency at CDN scale. So you could have really high number of subscribers all getting sub-second latency, which is very tricky to do in other ways. And I mean, I'll admit we don't have millions of viewers, live viewers for CommCon, but we could technically have it, by using Mock. The other interesting thing is you can do with the same architecture, you do on-demand video as well. And what this enables is this really cool seamless rewind feature. So this was actually mentioned yesterday as well. So basically, you could have viewers watching your live stream live, and then they decide, oh, I want to go back 5 minutes and rewatch something. So they essentially just slide back, and then they go back to the live edge again, and it's all very seamless and all in the same player. So that is, I think, a really cool user experience there. And because you're essentially handling all your packets by yourselves, then that opens interesting possibilities for inserting AI midstream. So, for example, for live transcription and analysis. So there are quite a few cool things that you can do with this, and I sort of wanted to try my hand at least some of this. Why now? So we've heard talks about mock for a few years now, and initially many of them were like how it works, what the protocol is. But for me personally, the light bulb moment came last year after 2 talks. One was Ali Began's talk at RTC On, and the other one was Luke Curley's at DMAX. And for me, this was the first time where we saw actually mock being used in practice. So what it looks like, and actually giving a demo of what it can do. So for me, there was a moment when I thought, okay, actually, I've heard mock, people talking about mock so long, but now I actually see it. Now I actually get it. So I wanted to, do something myself. So I show something myself as well. So the state of the protocol, it's still an ITF draft, very much in flux. So the evolution is very quickly. There's new drafts coming out fairly frequently, and everything is changing quite a lot. So it's actually difficult to keep up with all the changes. There are several, or at least a handful of open source projects out there. I've only listed a few here. And the thing is, because everything is is changing so fast, not all of them are necessarily at the same stage of development, and not all of them necessarily support the same features at the same time. So it might be a bit difficult to use them together, which is something I stumble upon, and we'll talk about that. As far as I know, nobody has live streamed a conference on mock before, at least not in this space. So I thought, let's use CommCon 26 as the guinea pig. So we'll be the first. So today I want to just give you a look at, well, essentially how I did it, which tools I chose, how I made them work together, and what I struggled with essentially. So a typical mock architecture has 3 players, 3 actors, I would say. So first there's the publisher. We used OBS with the mock OBS plugin so that we can actually do the stream. There's a relay in the middle, and we use Cloudflare. And then finally, there's a subscriber, and we use Mocktail with some custom code to actually handle the media. So on the publisher side, as I said, we use the mock OBS plugin, which is a fairly new, like a few months old plugin. So it's still obviously very much in development. In order to use it, basically I had to build an OBS fork so I could then build the plugin to put it into the fork. And because it's still WENU, it has some limitations, so we're limited to 720p video, H.264 in an XB, and we'll see why this is important. Raw AAC audio, and the libmock, which lives inside which is which powers the mock stream, targets mock drafts 15 and later. And again, we'll see how this impacted us. So we use Cloudflare for the relay, and I think this map essentially tells you why. So what Cloudflare has done, they've turned every single server in their network into a mock relay. So just by so I didn't want to deploy and maintain my own relay, but also by choosing Cloudflare, I get over 300 locations for free that I can use for relays. So I don't even need to choose which locations I want to support. I just get Cloudflare and I'm everywhere in the world. So it was a very compelling argument for us. It didn't come without trade-offs. So the biggest limitation is that Cloudflare Relay at the moment, well, it's an alpha release, and it's still on mock draft 14. So as we saw, mock OBS requires 15 and later. So in order to make the two talk to each other happily enough, I had to actually downgrade the version of the libmock inside the mock OBS so that it would actually sort of work with Cloudflare. It worked, the stream works, audio works, but obviously it's not a long-term solution, it's a bit of a hack. The other limitation with Cloudflare is that it doesn't even support, at the moment, obviously it's an alpha release, I can't complain, but it doesn't support all the mock messages that are described in draft 14. So as you can see here, it does support subscribe and unsubscribe, which means that we can do a live stream, but it doesn't support the fetch messages, which are required to request all their packets to the publisher, so which means we can't do video on demand, which already eliminates the possibility to do the cool rewind feature that I was telling you about, because you can't get old frames. You're only on the live edge with subscribe, essentially. So this was the biggest trade-off going in, because we chose Cloudflare. We say, okay, there's no on-demand possibilities for us, this year at CommCon. Then for the player, so we have essentially two sides on the player. There's a mock side and the actual handle in the media. So for the mock side, we use Mocktail. Ali Begum was here yesterday, talked about it a bit. So we use Mocktail as a client, and this was actually, honestly, the easiest part of it all. So basically, we just, initialize the client, and this handles all the mock messages with the relay. So here we see basically how we subscribe to the catalog. Another thing I didn't mention, actually, that's not supported by Cloudflare, is this subscribe namespace message, which essentially is a way to get updates from the publisher about which tracks are available, so you know what to subscribe to, and which is nice because it gives you updates essentially as events. The way you need to, what you need to do to know what tracks are available is you subscribe to a catalog track, which essentially only gives you a single message that contains a JSON, which tells you, what's available, so you know what you can subscribe to. And this is actually what we're doing here at the top. So we subscribe to the catalog, we read the object, and then we know the name of the tracks, and then we subscribe to the tracks separately. So this was the easy part. The other side of the player is the actually handling the media. So as we saw, we get separate audio and video tracks. From here, we need to manually read the mock objects in it, and then actually build the audio and video frame for player. And this was really the hard part. This is where I struggled most with, and I'll tell you a bit more about this in a minute. But first, I want to show you what it looks like when it works. So here we got the video. The right side is us playing the stream. And if you have a look at the details of the stream here we fetch the catalog, we subscribe to the tracks. Well, it's a bit hard to see, but basically you can see the name of the tracks we subscribe to and some details about the frames. So we see that frames are a couple of milliseconds old, and we can see there's a small drift between audio and video. We'll talk about that more as well. But this is when everything looks like this drift is very small, and you can see the latency is less than a half second. So obviously on the left we have OBS. I'm actually streaming. So I recorded this in Leeds. So we stream this. The packets are going to the Cloudflare server in London, and then it's coming back to my browser. So you can see we have less than half second latency, and when things work, they work very nicely. So let's have a look at the struggles of building the player. And actually, as I say, this is on the media side of things, not on mock, because actually just getting the packets is the easy thing. So we have two separate tracks, one for audio, one for video. So this means we also have two separate pipelines. So in the video pipelines from the publisher, we receive H.264 video in an XP packaging. This is essentially raw video data that we receive from the publisher. In order to play it, we need to decode it. So we need to use web codecs. Web codecs, though, expect AVCC packaging. These are just two different ways to package the same data. So converting from between the two is actually quite easy. We use Media Bunny, but the first small hurdle was that in order to do that, we had to actually patch Media Bunny to expose the internal tools it has to do the conversion. So it was just a initial little nag. But then, okay, we have the packets we need to decode them. So first, we initialize video decoder. And this is what we do here. So basically, we just give it a callback function for the output, which essentially just takes the frames and then it schedules it for playing later. And the reason why I can't just take it and play it is because we need to handle audio-video sync, and we'll see a bit later why this is important. So basically, yeah, we need to wait to play it. We can just play it as soon as it comes. So then, okay, reading the packets, the objects that we get from the mock stream, we put them in a stream loop. So we get a readable stream with mock objects. We read them in a stream loop. Next thing we do, handle packet delays. So we need to do this by hand as well. So we need to add some logic just to what to do when packets arrive with a delay. So this is just a very simple logic I added. If the packet is delayed, I'll drop it. If the lag is too high and I know that I just can't keep up, I'll just the easiest thing to do is just reset everything and resubscribe to the publisher, requesting the latest object when trying to keep up with the live edge again. When the packets do come in a reasonable time, then we need to trim the mock object header, and this is what the slice slice does there, so that we can actually just get the media out. Next, we want to decode it. In order to decode it, we need to initialize the decoder first. Well, actually, we need to configure it. In order to configure it, we need to get some config objects from the config data from the mock objects. So basically, we need to scan each incoming object until we get the decoded description. When we find it, we pass it to the decoder. We configure it, and at this point, once it's configured, next step is we need to wait for a keyframe. So we drop all the frames that we receive until we find the keyframe, so then so that we can actually start playing video. And then finally, we're almost there. We still got the raw media in NXB, so we convert it to AVCC. Then we pass it to the decoder, which will call the callback function that we saw earlier, which will actually schedule the frame for displaying later, which will write it to the media stream track generator, and that's when we're actually playing the video finally. Audio pipeline is quite similar. So we receive raw AAC frames from the mock publisher. We need an audio decoder to decompress the AAC, and then we need audio context to reproduce the uncompressed audio. So quite similarly, we initialize the audio context and the audio decoder. Again, we give it, we initialize the decoder with a callback function that schedules the audio for playing later for syncing. And here we also see the decoder configuration, which is just a little bit simpler than video. So in the audio loop, first thing we do, we initialize the decoder and configure it. So configuration here is easier. We don't need to scan the packets to find config data. All it needs is basically a sample rate and the number of channels, which we get from the catalog object we subscribe to at the beginning. So that's easy. If we didn't get the catalog, I would just fall back to 48 kilohertz and 2 channels, which is right because I control the publisher, so I know what I'm sending. Then this part is very similar to video. We read the stream loop. We handle packet delays with just the same simple logic as for video. Then we trim the mock object header, decode the audio data, pass it to the decoder that will call the callback function, which schedules the playing for later. So I've already mentioned AV sync a couple times now. This was actually quite crucial and quite difficult for me in the end. We get these two separate streams sending objects to us, and we somehow need to play them at the same time so that it makes sense. Luckily, every mock object comes with a capture timestamp header, which comes from the publisher. This is the only timeshare reference within the two tracks. There's nothing else that we know, but in principle, we can use this for scheduling. So if we're able to take two frames, an audio and a video frames that have the same capture timestamp and play them at the same time, then everything will be in sync. So in principle, it's doable. In practice, it was very difficult. And if you've seen the stream, it doesn't work very well. So this is sort of the simplified way how I did it. So on the video side at the top, it's relatively easy. I just play the video frames. I write the video frames to media stream track generator with a set timeout, and the delay millisecond essentially targets a fixed latency that I set at 100 milliseconds. So basically, that's the buffer I give myself to play things, hopefully, keeping them in sync. And if something gets a bit delayed, then I just essentially set a smaller delay for set timeout, so the frame plays a bit later and sort of keeps up with small delays. It's not quite as simple for audio. The main problem essentially is that when packets come in late and come in all at the same time, they would try to, all the audio nodes would try to play all at the same time, all at the same time, which means, when they overlap, they cause robot voice distortion. So in order to try and avoid that, I had to add an anti-overlap floor, which basically is just a small delay that ensures that all nodes play sequentially. So they don't overlap, but this means that even though the logic is sort of able to recover if there's small delays, in practice, it's very slow at doing that, because you can't cancel nodes once they start playing. You need to play them, and you can't play them, overlap them, because they will cause distortion. So you're trying to keep up, but at the same time, you sort of hold them back. So all this does essentially was just show how difficult it is to solve this problem in practice. And yeah, if you've seen the stream, you have noticed that it doesn't always work very well. So I've got an example when things don't quite work as well. So this is an unlucky stream where basically when we start the player, we subscribe to the streams. It's probably a bit difficult to see, but basically when we start, we're already late. Audio here we see is degraded, is about 3 seconds delayed compared to the video. So the video looks fine. It's the latency is good, but the audio is just taking forever. Now it's down to 1.7 seconds delayed compared to video. So it's frame by frame, it's trying to catch up, but it's just too slow. At some point, it will just realize, there it is, audio stalled, it's not gonna happen. So what it did here is basically, it determined that we're just too late. It reset everything, it subscribed again to the tracks, to the latest object. And now things says, like, now this time it was lucky, audio okay. So this means that we were able to catch up again, and there's no delay, and things are ticking along nicely again. Many times this is not quite the case. We need to reset the stream more than once, and this is just showing basically how my delay handling logic is just too simple to actually give a good user experience. Just there's more work to be done there to actually make it work nicely, essentially, which just shows how difficult everything was. Obviously, I made it work. It sort of works most of the time, but it also shows if this was to be a sound user-facing product, there would be a lot of work to do just to optimize it to make a good user experience, essentially. Incidentally, now that we got the end to it, you can see we got like less than 300 milliseconds latency. So when things work, they work very well. So essentially, just giving you a glimpse of some things that I struggle with. There were a lot of instances where I had just to do things myself, do them by hand, and it felt sort of like reinventing the wheel. So just to, think back to a couple of these. So we've seen the difficulties with late packets. So when the player falls too far behind, the publisher will realize that the subscriber is not going to be able to catch up. Essentially, it can abort sending, and what I would typically hear is audio just stops playing. Audio, as we saw, is just more difficult. So it's the first thing that tends to fail in this case. So I've added some logic for a skip window to drop packets to sort of try to avoid that. When things go bad, I added the resubscribe logic as well. And there was a small cooldown guard to make sure if things go very bad, we don't try and resubscribe too often. And these are all like sort of arbitrary thresholds that I thought, they sound reasonable, but obviously there's a lot of optimizations that we can do around this. But I very soon realized that in order to be able to do all of this, I had to write my own QoS, because you need to be able to realize that you have late packets in the first place, and also get a sense of how late they are. You need to be able to realize that you have stalled tracks, and you need to be able to do this both for audio and video independently. So essentially, what you realize here is that every other stream stack out there already does this under the hood. We just never really think about it, or maybe we don't really appreciate it enough. There is obviously all the other stacks are much more mature. They've been around loads, and they have much much more clever solutions to handle this than my little quick code that I try to put together to solve the problems quickly. So there's another thing I haven't mentioned yet. What about Safari? So going into mock, and I came in like sort of very naively, I suppose. I sort of had this assumption that, well, mock just isn't going to work on Safari. So I sort of accepted it. And actually, if you have tried and look at the stream on CommCon in the past couple of days on your iPhone, you have noticed that the mock option is unavailable on your device. And so this is the actual reason why. So as we said, we get raw video frames from the publisher in an XP packaging. So in order to be able to make them make sense for a video element to play in the browser, we need to decode them, and to do that and to play them, to push video frames, we need a media stream track generator. Media stream track generator is a Chromium only API, and as it turns out, recent Safari versions do support web transport, but they don't support media stream track generator, which is the actual reason why the stream on the CommCon website doesn't work on your iPhone. So essentially, the main reason is because we're getting unXP frames. But unXP is not the only packaging format out there. There's CMAF, for example. So what about CMAF? So this is a standardized format for packaging media. Obviously, there's others, but just looking at this one, what it allows you to do is to feed the segments directly into a media source for playing. A media source is a very widely supported API that's available on all modern browsers, including Safari and Firefox, by the way. So we are sort of in our example here for this stream, for the live stream, we're sort of cut out of this because the libmock that allows the mock stream for OBS doesn't support at the moment CMAF, so it only gives an XP. But if we did get CMAF frames from our publisher, what would change? So we wouldn't need video coder and audio decoder. We wouldn't need media stream track generator. We wouldn't need audio context. Wouldn't need to convert an XP to AVCC because the packaging we get is already accepted by the browser. We wouldn't need to wait for a keyframe to start playing. We wouldn't need to do our manual AV sync, and we wouldn't need a separate audio track subscription. We would get one track with multiple streams. What we still would need to do is you still need to subscribe to the catalog and to the track via mock, so the mock side remains the same. You still need to remove the mock object wrappers, but you do this differently. So with CMAF, you're able to locate the move box, and so you know what to remove from the object to just get the media data out. So there's no slicing 4 bytes blindly and hoping for the best, like I did. And then finally, you just feed the media bytes to media source, and essentially it plays. So again, getting into mocks a bit naively, I thought, well, I thought also had this sort of assumption that, well, mock equals web codecs. It's just a thing, I will need to do that. That's actually not the case. Web codecs are not a requirement if you want to do mock. They are a requirement if you want to handle raw media, which we had to do. But you can just, not get raw media, and you can do mock without mock web codecs. In fact, when you choose a different package, the player code they have could be much simpler than the one that I had. So essentially, mock can be supported on Safari, could be supported on mobile, anything. Obviously, if you did want to go this way, you would give up some low-level control. So what this really means is it really depends on your application. So in my case, what I want to do ideally was a simple live stream that's available on as many devices as possible and gives a good user experience. So CMAF packaging or something similar that makes things easier on the player and essentially would actually make a lot of sense. If your application needs low-level control, you need raw media. So for example, Lorenzo yesterday talked about converting mock into WebRTC. So in that case, I suppose it would make sense to get something like AnnexB like he does and convert it to AVCC. Or actually, for that matter, you could just be sending AVCC for mock directly, and you don't even need to do the conversion. In that case, if you were getting CMAF, you would need to actually do a lot of work to make it work into, to convert it to WebRTC. So it really depends on your application, on your needs, really. But what's actually cool about this is because with mock, you're just sending objects, you can just, if you decide, and if you're able to decide in advance, you can just say whatever works best for you in the rest of the pipeline. So in conclusions, we did stream mock. We did stream CommCon 2026 with mock. So we have done it. I have proof. It wasn't as easy. The user experience wasn't particularly great, but it's done. So what I've learned, as far as I know, this is the first conference to do a live stream with mock, at least in this space. So technically, mock in production today is possible with a big asterisk and a lot of caveats. Obviously, this is more like a proof of concept that, a production product, but we've seen why. There was a lot of trial and error. Obviously, time constraints means that, I need to simplify the way they solve the problems. But it actually showed me that some of the difficulties were almost like self-inflicted. If you choose the right packaging format for you at the beginning, you can make your life much easier, and everything else, in the rest of the pipeline would work much better. And well, just in general, choosing your tools means choosing your constraints. And obviously this is true always in engineering, but I think even more so in a project that is so new, so quickly evolving, and when you're working with tools that are in beta development, beta stage, or even alpha, like Cloudflare Relay. Big learning here is also, if you're doing this in production, have a backup and know what's at stake. So CommCon is an in-person event with a live stream. It's not a virtual event. And even so, we've been streaming on YouTube. We've got HLS. We're not just relying 100% on mock. So the stakes here are not very high. And it's quite important. It means, removes a lot of pressure. You can still provide, essentially the user experience that you need. But at the same time, we've been doing this technically in production. So the final question is, would I do it again? So I'm sure this is not the last of it of mock for us at Nimble Ape and with CommCon. There's still there's a lot. It feels like we've just been scratching the surface. There's a lot of potential there. There's all those nice features that I couldn't really get my hands on because of other constraints and time as well. So yeah, this is definitely not the last of it. That's definitely the next time I'll be very conscious of the tools I choose and what they support, and not based on what I want to get out in the end. And definitely I'll know what I'm getting myself into. Thank you.
Hello. Thank you, Marco. Any questions? Many questions. I'll come to Tim first.
So I've got an infinite number of questions, but I'll stick with two for the moment. First one is, would it be useful if the media stream track generator could accept audio as well as video? I mean, it's a question that cropped up in the WebRTC working group, and there's a big argument going on at the moment, and I don't know which way to vote, so I'd like your advice on that. And then the second question is, I didn't see any talk about doing things in web workers. Is that a deliberate decision, or doesn't it work, or did you just like not talk about it because it complicated the slides?
Right. So getting audio in a stream track generator, I think my first instinct would be yes. I think it would be helpful. It's like, I'm not sure like if that would mean is this like gonna automatically solve the problem of syncing or not? Because just so the problem I had was not just playing audio directly in an audio buffer in the browser is not a particularly elegant solution. I'd rather put everything on on a video tag essentially. But playing the audio itself wasn't the main problem. It was just keeping the two things in sync. So because they were running on two separate buffers, essentially, each with its own clock, I had to do the work myself to keep things in sync. And even when things work very well, I can still measure like at least a 20-60 millisecond drift between the two, because it's just difficult to get them to play right at the same time. So if just sort of plumbing them in together in the same thing that keeps them in sync work, then it would be beneficial. But as I said, if my use case sort of I suppose the line here was if my use case requires me to handle raw data, then it sort of means that you sort of have to be prepared to do a lot of manual work yourself here or there anyway. If that's not the case, then I would just cut the problem at the source and use something that gives me things that are going to be in sync rather. So I'm not too sure specifically about media stream stack generator, how that is going to affect things in practice. Like the ISTIC will be probably helps. I'm not sure if it still means there's still going to be a lot of manual work around there. Second question was web workers. So I'm not too sure. So I sort of just try to get things to work. So it's not like I didn't get into it in the slides. I think I just went away in my solution that sort of worked like that. So I have the audio loop and the video loop, essentially two separate loops for the decoders, and just play them, and that's it. So I try to keep things simple, but as I said, it's in several parts it's a bit of a hacky solution, so I'm sure there's better ways to do things.
Regarding the on-demand, you mentioned that there's incompatibility between mock OBS and Cloudflare mock versions. Once that is compatible, will you try to do the on-demand?
Yes. So there was like one of the things that I really wanted to do was being able to do the rewind, or in general just on demand, because at that point you can do like in the same player you can do live, but you could actually do on demand, like showing yesterday's talks and so on. So I would definitely do it. There's a bigger question mark there whether going with Cloudflare is the actual, the actual solution going forward or not, because obviously the Cloudflare network is is incredibly compelling, but at the same time, I was itching during this project, thinking, what if I actually were able to control my own relay and have things, first of all, things that are on the same draft, so at least they work well together, and it's something that supports all the types of messages that I want. So there's that. So yeah, short answer is I would definitely want to do fetch commands as well. Whether there will be with Cloudflare, if there's like more work, yet more advancements in the Cloudflare relay, I definitely will. If not, I might be tempted to try my own relay in order to do that.
So first, we have a cool presentation, of course, and I have a couple of questions. I actually have just still many more, but I'll bother you later with those. I have mostly a couple of questions, one related to audio and one to video. So the audio that was accumulating delay, I was curious whether or not you know if audio was going over datagram or over stream, because in theory, as Ali said, it's recommended to have audio over datagram because it doesn't really need to be retransmitted and it shouldn't be impacted that much by delays and so on. And so whether when you say that you would reconnect streams, you would just resubscribe just to the audio track, or you would basically do everything from scratch. And then second question on video, considering that media stream track generator is not available universally, did you consider as an experiment using a canvas instead of going to video directly as a way to render video to those browsers that don't have support for that?
Right. So first part about audio, I'm not sure. I don't know whether it was going on datagram or not. I was honestly just receiving the packets and trying to make sense of them. So I can't really answer. I'm not sure. Was there another part to the audio question? Oh yeah, resubscription. So yes, what I do is just at that point, it's just easier to just unsubscribe to everything and subscribe to both tracks again, just to start fresh, essentially. Because what wasn't really clear in that example, but it happens in practice a lot, is once, I think it has to do with the fact how I try to play audio video in sync. Once audio starts to be delayed quite a lot, video will soon follow anyway. So it's just easier to discard everything and subscribe to the latest object. Anyway, it's like the easiest part of it all is there's not really a lot of overhead. You just subscribe again. Regarding Canvas, I am really against the idea of using Canvas if I have a video tag. So I really don't want to do that. I've seen it, like I've seen, I think Luke's Hang or his Hang.live website uses Canvas, I think. I just really don't like it because there's a video tag and we should be using video tag, to be honest.
A couple of things on the relays. So I know mock is brand new to me this week. So this was kind of probably mentioned yesterday, but I'm not understanding it. So you said like Cloudflare's got 300 relay nodes or whatever, but your publisher running on that box in the corner there, are you having to therefore publish to every, or at least every relay that's used? Because I thought this is, relays couldn't relay to relay. There's no fan out.
I guess so. I guess in principle they can. In practice, I'm not sure if Cloudflare does it. I would assume it probably doesn't.
But you're pushing one single stream.
Yes.
From here.
Yes.
To
so
Cloudflare.
The way this works is the subscriber on the final device points to Cloudflare. So Cloudflare has one URL, but then because the way it works, I think you just talk to the local server, which is a relay, which in that case I think just goes, I assume, directly to the publisher here. wherever it is, and then gets the packets to the request to the public, because each relay is essentially a subscriber and the publisher in itself.
Yeah. So the relays
so it
then subscribe to
subscribes
your
that,
machine.
yes, and then it just publishes to the end user again. So I suppose in that case it does mean that.
But every active relay at least. So if you had 300 users hypothetically completely geographically dispersed onto 300 different relays, you'd get 300 connections to your machine.
No, I think Cloudflare might be multicast internally.
Okay.
Lands on one inbound relay and then spread.
So they do some internal, yeah.
If it's a huge single relay.
So
Multicast internally.
Yeah.
I think.
Okay. So yeah, you would think that the same way they do those, any other routing, you would accept they do the relay as well. I don't have any details of
normally
how
do
they
sort
do
of
it in practice.
caching. Yeah, I'm just trying to figure out if, for a small scale audience, no offense, Dan, but yeah, it's actually kind of, is the relay giving you that much like benefit, or is it almost just, if you've got one subscriber on every relay, there's no point in using the relays?
I think so. I think in practice you sort of need the relay in between. You wouldn't I don't think that the idea is that you wouldn't have a subscriber just going to the publisher. But I don't think in practice we for this conference we're not really benefiting from Cloudflare and actually it's just talking about Cloudflare. I had a feeling that because I had to downgrade libmock in there, and because Cloudflare is on a different version, sometimes some of the glitches might just be because of something that's in between before it even reaches the subscriber. So there's surely a lot going on in the whole route.
And finally, are you paying Cloudflare charging for the relays at the moment? Or was it all just free?
No,
Well, you have to have an account presumably, but yeah.
Yes, it's free because it's an alpha release, so that it's just essentially testing. And I'll have to admit, we don't have millions of watchers on CommCon, so.
No, do we not?
Well, we don't count them, so they might be there.
There are millions, trust me. Thank you very much, Marco.
Thank you.
Mock is a funny one to me. All the benefits of mock are low level, but then low level equals a huge amount of pain, and you have to have the same version of everything everywhere, otherwise more pain. Or you can go down CMAF route, but then you don't get all of the benefits of mock. So yeah, or you could just use WebRTC and everything kind of just works with a bit of setup time. Anyway, we are at the end. Thank you very much for coming. I should have my laptop. We should thank all the sponsors. My laptop's over there. Anyway, SIPGate, thank you very much for hosting us. And SIPFront, oh, thank you. Hold on. I was too engaged in the mock debate. There we go. Right. Thank you very much to SIPFront, our platinum sponsor. SIPFront have supported us an awful lot over the past however many years since SIPFront basically began. Gold sponsors aren't going to load. I should know. They're me. Nimble Ape and Everycast Labs. Silver sponsors Toulouse. Toulouse has sponsored every single CommCon ever. So thank you very much to Toulouse. Software Mansion, Jambones, Cloudflare, SIPHub, and QXIP. Thank you very much to our silver sponsors. And then our community sponsors. Community sponsors are actually the best because they give us money with they don't want anything in return at all. So WebRTC Ventures and the VCOM Foundation. But yes, lastly, thank you to SIPGate. Without SIPGate, this one wouldn't have happened at all. That's it. Thank you very much. All the talks will be The 2 live streams are online right now, but the talks will be cut up, etc., and posted individually next week, hopefully. That's it. Thank you very much. Have a good journey home.